Welcome students to the course on coordinate geometry. Our very first topic is Cartesian coordinate system. Cartesian coordinate system. So let us first discuss what Cartesian coordinate system is. Cartesian coordinate system is nothing but a system of two perpendicular lines x dash ox and y dash oy. A system of two perpendicular lines x dash ox and y dash oy meeting at a point O. Meeting at a point O. So this system of two lines meeting at a point O constitute the Cartesian coordinate system. And the plane defined by these two lines, which is the plane you're seeing, is called the xy plane. Plane defined by the lines x dash ox and y dash oy is called the xy plane. And x dash ox is called the x-axis, y dash oy is called the y-axis. X dash ox is called the x-axis, which is usually horizontal, not always, which is usually horizontal, and y dash oy is called the y-axis. And the point where these two axes meet is called the origin, usually represented by O. So O is the origin. Now these two axes combinedly are called the coordinate axis. So these two axes are called the coordinate axis. Now in the coordinate axis, this part OX, which is on the right side of y dash, is called the positive x-axis. This is the negative x-axis. OY is called the positive y-axis. OY dash is the negative y-axis. That is, the distances measured along this direction, along the direction of positive x-axis are positive. The distances measured along the negative x-axis are negative. The distances measured along the positive y-axis are positive. The distances measured along the negative y-axis are considered as negative. So this is the positive x-axis. So we denote the numbers 0, 1, 2, 3, 4, so on. These are the units on the positive side of x-axis. And minus 1, minus 2, minus 3, so on. These are the distances on the negative side of x-axis. 1, 2, 3, so on. These are the numbers on the positive side of y-axis. Minus 1, minus 2, minus 3, so on. These are numbers on the negative side of y-axis. So this is the positive x-axis, positive y-axis, negative x-axis, negative y-axis. And all these combinedly are called the coordinate axis. Now, every point on the xy plane, can be uniquely defined in terms of an ordered pair containing two numbers. So every point on xy plane, can be defined uniquely, can be represented or represented uniquely. This is an important point. Uniquely with an ordered pair x comma y, where x is called the x coordinate of the point and y is called the y coordinate of the point. That means if you take any point on the xy plane, it corresponds to a unique ordered pair x comma y. X is called the x coordinate, y is called the y coordinate. And these are called the Cartesian coordinates. X comma y are called Cartesian coordinates. And what is the definition of Cartesian coordinates? So if you take the x coordinate The definition of x coordinate is the distance of this point from y-axis. The distance of the point from y-axis measured in the direction of x-axis. The distance of the point from y-axis measured in the direction of x-axis. That is, you go from y-axis and measure the distance of this point from y-axis in the direction of x-axis. You should not go in any direction. You should go in the direction of x-axis. So as you can see, this distance is called the x-coordinate. And what is the y-coordinate? Y-coordinate of a point is defined as the distance of the point from x-axis measured in the direction of y-axis. So start from x-axis, measure the distance of the point in the direction of y-axis. So this will be the y-coordinate of the point. So as you can see from this figure, so this distance will be exactly same as this distance is found to be 1. So the x-coordinate of this point is 1. As you can see, this distance is exactly same as this distance. So the y-coordinate is 2. So the coordinates of this point are 1, 2. So this point corresponds to the ordered pair 1, 2. So if you take any other point, let us take this point. What are the coordinates of this point? Again, there are two coordinates, x-coordinate and the y-coordinate. The x-coordinate is defined as the distance from y-axis measured along x-axis. So this distance will be the x-coordinate. So you start from y-axis and measure the distance. So as you can very clearly see, the direction in which you are going is the negative x direction. The direction in which you are going is the negative x direction. So you're going along negative x. So the distance also has to be measured as negative numbers. So negative just represents the direction in which you're going. If you're going along the positive x-axis, you take the number as positive. If you're going along the negative x-axis, you take the distance as negative. So the distance is 2, but in the negative x direction. So the x-coordinate is -2. Now, what is the distance of this point from x-axis? So start from x-axis, measure this distance. As you can see, this distance is exactly same as this distance. And this is the positive y direction. This is the positive y direction. Hence, the length is 1 in the positive y direction. So the y coordinate will become 1. For example, if you take a point in this part. So let us take this point. So now what is the distance of this point from y-axis? That's the x-coordinate. So start from y-axis, measure the distance. So you can very clearly see that this distance is 3 units, but in the negative direction. So the x-coordinate will become -3. And what is the distance of this point from x-axis? So start from x-axis, measure this distance. So you can very clearly see that this is also 3 units, but in the negative y direction. So the coordinates are -3, -3. So there are two important things. You measure the distances following a standard convention. So you have to measure them in this convention. So the distances measured in the direction of positive x-axis are positive. The distances measured in the direction of negative x-axis are negative. Similarly, positive y-axis direction, y-coordinate is positive. Negative y-axis direction, y-coordinate is negative. So what is the x-coordinate of the point? X is called the x-coordinate. X is called the x-coordinate, or is also called abscissa. This is a common name. What is the abscissa of a point? That means what is the x-coordinate of a point? So abscissa or x-coordinate is defined as the distance from y-axis. The distance from y-axis. If you want the x-coordinate, you want the distance from y-axis. And measured along the direction of x-axis. Measured along x-axis direction is called the x-coordinate. Similarly, what is the y-coordinate? So y-coordinate is usually called just ordinate. So what is the ordinate of a point? Again, it's the distance from x-axis measured along y-axis. Okay, so this is the distance from x-axis measured along y-axis. Okay, so again, the sign is important. If you measure in the direction of positive x-axis, the number is positive. Negative x-axis, the number is negative, so on. Now, with respect to the coordinate axis x dash ox and y dash oy, the whole xy plane is divided into 4 parts. The first part, second part, third part, fourth part. And each part is called a quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. And in the first quadrant, if you take any point, both the x coordinate and y coordinate are positive numbers. So you can see very clearly, because if you take any point on this quadrant, the distance along x-axis is also positive, the distance along y-axis is also positive. If you take the second quadrant, the x coordinate of any point on this quadrant is negative and the y coordinate is positive. And if you take the third quadrant, the coordinates are both negative. And in the fourth quadrant, the x coordinate is positive and the y coordinate is negative. So these are called the 4 quadrants, and depending on the quadrant, the signs of the coordinates of the point changes. So coordinate geometry is a branch of mathematics which studies different curves by representing the points by the ordered pairs x, y. This ordered pair x, y is also called Cartesian coordinates. So coordinate geometry. This is a branch of mathematics where different curves are studied by representing the points on them with Cartesian coordinates. So in coordinate geometry, we employ algebraic method to solve geometric problems. Algebraic methods to solve geometric problems. Because once we represent the point by numbers x, y, we can employ the algebraic methods where you represent the unknowns by variables x and y. So this branch of mathematics is also called analytical geometry. Analytical geometry. So coordinate geometry is also called analytical geometry, and what this branch of mathematics tend to do is it combines algebraic methods with geometrical problems so that geometrical problems can be solved more easily. So now, once we understand the coordinate basics of the coordinate geometry, so we can go forward. So the important things that you need to understand about coordinate axis are that 1, so the coordinates of origin are 0, 0. So origin has coordinate 0, 0 because the distance of origin from x-axis as well as y-axis is 0. And any point on x-axis. So any point on x-axis is of the form some x, 0. The y-coordinate of the point on x-axis is equal to 0. So if you take any point on x-axis, the y-coordinate will be equal to 0. Similarly, and any point on y-axis, any point on y-axis is of the form 0, y. Means the x-coordinate of any point on y-axis is 0. The y-coordinate of any point on x-axis is 0. the x coordinate of any point on y-axis is 0. That means if you have this point which is at a distance of 1 unit from origin and on x-axis, the coordinate of this point will be 1, 0. The coordinate of this point will be 2, 0. The coordinates of this point will be minus 1, 0. The coordinates of this point will be 0, 1. The coordinates of this point is 0, 2, so on. So if you take any point on x-axis, the y coordinate will be equal to 0. If you take any point on y-axis, the x coordinate will be equal to 0. In this video, let us look at what polar coordinates of a point are. So we have already seen that in a Cartesian coordinate system, we have x-axis and y-axis, and if you take any point P on this xy plane, you can represent them using two coordinates x and y, where x coordinate is the distance from y-axis and y coordinate is the distance from x-axis. So this is one way in which we can uniquely represent a point using two distances. Now let us see another way in which we can represent this point by using a distance and an angle. So for example, if I want to represent this point, so what I try to do is I'll try to join the origin with this point P by a ray. So let us draw the ray OP. Let us draw the ray OP that is starting from the origin and joining the point. And let us say that the distance between O and P is R. That is, P is at a distance of R from origin. So if I give this information, we know that P is at a distance of R from origin. That means P has to lie somewhere on a circle with origin as center and radius is equal to R. Now let me give another information that OP is making an angle of theta with the positive direction of x-axis. That is, using the standard convention of trigonometry. That is, counterclockwise angles are positive, clockwise angles are negative. So OP bar has a length of R and OP bar makes an angle of theta with the positive direction of x-axis. So now instead of x and y, if I give you R, theta. So using these two numbers also, you can uniquely define the point which these coordinates represent. For example, if I say the point P is 1, minus pi by 4. So what point does these coordinates represent? So this says that point P is at a distance of 1 unit from origin and OP bar is making an angle of minus pi by 4 with x-axis. So to get this point, first what you do is you draw a circle with radius is equal to 1 about origin. So let us say that this is a circle with radius equal to 1. That means every point on this circle is at a distance of 1 unit from origin. Next, I want a point on this circle such that OP bar makes an angle of minus pi by 4 with x-axis. Minus pi by 4 means pi by 4 in clockwise direction. So you rotate the ray through an angle of minus pi by 4. So this will be the terminal ray. So any point on this ray has an angle of minus pi by 4 with x-axis. Any point on this circle will have a distance of 1 from origin. So now I want a distance of 1 from origin as well as an angle of minus pi by 4. So this will be the required point 1, minus pi by 4. So instead of x and y, we can represent the points using r, theta also, and these coordinates are called polar coordinates of the point. These are called polar coordinates of the point. Now, the important thing that you need to understand about the polar coordinates are that they are not unique. That means this point might have more than one polar coordinate. For example, 1 comma minus pi by 4 is exactly same as 1 comma 2n pi minus pi by 4. This is something we have learned in trigonometry. Because even after one rotation, the ray stops here. Even after two rotations, the ray stops here. Because angle is a periodic quantity. It just goes on the position of the ray goes on repeating itself after every rotation. So minus pi by 4 is also same as 2 pi minus pi by 4. So if I want to rotate the angle 2 pi minus pi by 4, again the ray stops here. So something like if I write 2 pi minus pi by 4, 7 pi by 4 also represents the same point. So what you need to understand is a polar coordinate of the point of the form r comma theta is exactly same as the coordinates r comma 2n pi plus theta. So these two represent the exact same point. So n can be any integer. So once you understand what polar coordinates are, what you need to be able to do is convert from one type of coordinates to other type of coordinates. That is, if the polar coordinates are given, you should be able to derive the Cartesian coordinates. If Cartesian coordinates are given, you should be able to derive the polar coordinates. So let us see how to get one system from the other. So in this video, let us look at how to convert one set of coordinates from another set of coordinates. So let us say that in the coordinate system x dash and y dash, you have a point P whose Cartesian coordinates are x and y, and the polar coordinates of the same point be equal to r comma theta. X and y, r comma theta are coordinates of the same point, one in Cartesian system, the other in polar coordinate system. Now if r comma theta is given to you, can you get x comma y from that? If x comma y is given, can you get r comma theta? So that's the question that we are going to deal. Now what is the relation between these two? So in the definition of trigonometric ratios, we have seen that if a ray makes an angle of theta with the positive direction of x-axis, and if x comma y is any point on this ray at a distance of r, sine theta is nothing but y coordinate by r, cos theta is nothing but x coordinate by r. So this implies, can I write x is equal to r cos theta, y is equal to r sine theta. So this is how you get x and y from r and theta. So the Cartesian coordinates x comma y are nothing but r cos theta comma r sine theta. So that's the conversion from polar coordinates to Cartesian coordinates. For example, so if you have the polar coordinates 1 comma minus pi by 4, which I have already discussed, the Cartesian coordinates of 1 comma minus pi by 4 is nothing but 1 times cos minus pi by 4 comma 1 times sine of minus pi by 4. That is equal to 1 into cos minus pi by 4 is equal to cos pi by 4 1 by root 2. So 1 by root 2 comma sine minus pi by 4 is minus 1 by root 2. So the coordinates are 1 by root 2 comma minus 1 by root 2. So 1 minus pi by 4 is the polar coordinate correspond to the point. The Cartesian coordinates correspond to the same point is 1 by root 2 comma minus 1 by root 2. Next, if you have 3 comma 2 pi by 3. So what are this is the polar coordinates. What are the Cartesian coordinates of the same point? So r times cos theta, r times sine theta. That is 3 cos 2 pi by 3 and 3 sine 2 pi by 3. that is equal to 3 cos 2 pi by 3 is minus 1 by 2. So minus 3 by 2 comma sin 2 pi by 3 is plus root 3 by 2. So we have 3 root 3 by 2. So I hope you have understood how to convert polar coordinates into Cartesian coordinates. Just the formula is r cos theta comma r sin theta. So now let us try to see how to do the reverse question. Now, if x and y are given, so how do you get r comma theta? So let us say that the Cartesian coordinates of the point are given. Now, the meaning of r is nothing but the distance of this point P from origin, right? So what is the distance of point P from origin? So r is nothing but root of x square plus y square. That is the distance of the point x comma y from origin. Or you can also square this and add this from these two equations. X square is equal to r square cos square theta. Y square is equal to r square sin square theta. So if you add these two, x square plus y square is equal to r square times sin square theta plus cos square theta is equal to 1. This implies r is equal to root of x square plus y square. R is equal to root of x square plus y square. So this is the formula for r. Now how do you find theta? So if you divide one by the other, so y by x is equal to r and r gets cancelled. So you get tan theta. So this implies theta is equal to tan inverse of y by x. So but the problem here is corresponding to a theta, corresponding to a tan theta, theta is not unique. So we know that tan theta is equal to some number gives you two principal solutions. Tan theta is equal to any number gives you two principal solutions, not just one. But I want the correct theta. So I want only one principal solution. So how do we get this? For example, if you have a point in the first quadrant, So for example, let us say that you have the point 1, 1. You have to find r and theta correspond to this. So r is very simple, root of 1 square plus 1 square is equal to root 2. Now, if I write tan theta is equal to y by x, 1 by 1, this implies theta is equal to tan inverse of 1. So tan inverse of 1 can be thought of as pi by 4 or an angle in the third quadrant, 5 pi by 4. So corresponding to pi by 4 as well as pi plus pi by 4, tan theta value will be equal to 1. So but pi by 4 and 5 pi by 4 both will not be the correct answer for this point. So the correct answer for this point will be root 2 comma plus pi by 4 because this point is in the first quadrant. So if the point would have been in the third quadrant, then root 2 comma 5 pi by 4 would have been right. So directly I cannot use this. So you have a two-step process to find theta. So first step is find theta is equal to tan inverse of modulus of y by x. It is irrespective of what the signs of x and y are. Take mod y by x and find tan inverse and find a theta in the first quadrant. So find a theta in the first quadrant. Now according to the quadrant of the point, depending on the signs of x and y, you know the quadrant. So depending on the quadrant, you find the allied position in the corresponding quadrant. So the second step will be, so according to signs of x comma y, according to the signs of x and y, we can find which quadrant the point lies in. So according to the signs of x and y, find the corresponding allied position, allied angle. For example, if you get theta is equal to pi by 4, theta is equal to pi by 4. Now the point has the points x and y, the coordinates x and y are such that x is negative and y is positive. That means the point lies in the second quadrant. So what is the allied angle to pi by 4 in the second quadrant? Pi minus pi by 4. So if you get theta and point in the second quadrant, the angle will be pi minus theta. So if you go to the third quadrant, so I can write the angle as pi plus theta. So pi by 4 in third quadrant will become pi plus pi by 4. Now in the fourth quadrant, the angle is just minus theta. If the allied angle is pi by 4, the corresponding allied position in the fourth quadrant will be just minus pi by 4. So to find r is very straightforward, root of x square plus y square. To find theta, first we find the allied angle in the first quadrant, and depending on the quadrant of the point, we change this angle correspondingly. Now let us see some standard examples. So in the first set of examples, let us convert from polar coordinates to Cartesian coordinates. So this is a very straightforward conversion as we have seen. So r and theta are given to you. So the x and y coordinates are nothing but r cos theta, comma r sin theta. As simple as this. So you have 2 times cos pi by 6 and 2 times sin pi by 6. That is equal to cos pi by 6 is cos 30 degrees, which is root 3 by 2. 2 root 3 by 2 is root 3. And 2 times 1 by 2 is 1. So root 3, comma 1 are the Cartesian coordinates. Next, if you have 3 comma minus 2 pi by 3. So again the formula is same. 3 times cos minus 2 pi by 3 and 3 times sine of minus 2 pi by 3. That is equal to cos 2 pi by 3 is same as cos minus 2 pi by 3 is same as cos plus 2 pi by 3, because theta minus theta doesn't matter in cos. And 2 pi by 3 is 120 degrees. So we know that cos 120 is minus 1 by 2. 120 lies in the second quadrant. So cos 120 is minus 1 by 2. So 3 times minus 1 by 2 is minus 3 by 2. And 3 times sine minus 2 pi by 3 is minus sine 2 pi by 3. So you have a minus 3 into sine 2 pi by 3. It is sine 120 degrees is root 3 by 2. So minus 3 root 3 by 2. So you can very clearly see that you got a point in the third quadrant. Minus 2 pi by 3 is minus 120 degrees. So minus 120 degrees, you get a point in the third quadrant. You also got a point in the third quadrant. So the signs will automatically be managed. You don't need to do anything extra. So 4 comma 5 pi by 6. So 4 cos 5 pi by 6 and 4 sine 5 pi by 6. So 5 pi by 6 is 150 degrees. Second quadrant, cos is negative, sine is positive. So 4 times cos 5 pi by 6 is minus root 3 by 2. And 4 times sine 5 pi by 6 is plus 1 by 2. That is equal to minus 2 root 3 comma 2. Minus 2 root 3 comma 2. Next 1 comma minus pi by 3. 1 cos minus pi by 3. 1 sine minus pi by 3. So cos minus pi by 3 is same as cos plus pi by 3. You get 1 by 2. And you get minus root 3 by 2. So these are the 4 conversions from polar coordinates to Cartesian coordinates. Very straightforward. Now, in this set of examples, let us do the conversion from Cartesian coordinates to polar coordinates. So let us take the Cartesian coordinates 3 comma 3 root 3. This is x and this is y. Now you are asked to convert them into polar coordinates r comma theta. The formula for r is very straightforward. R is equal to root of x square plus y square. 3 square is 9. 3 root 3 whole square is 27. So root of 9 plus 27 is root 36 is equal to 6. So the r coordinate is 6. Now you're asked to find the theta also. So theta is a two-step process. So first, irrespective of what the signs of the x and y coordinates are, find theta is equal to tan inverse of mod y by x. So theta is equal to tan inverse of 3 root 3 by 3. 3 root 3 by 3. And tan inverse of root 3, you get an angle in the first quadrant. So in the first step, you try to find an angle in the first quadrant which is allied to this. So pi by 3. Now in the second step, go to the quadrant of this point. So for this point, x coordinate is positive, y coordinate is positive. That is, the point lies in the first quadrant. Hence, what is the allied position to pi by 3 in the first quadrant? Pi by 3 itself. Hence, theta will be equal to pi by 3. Next, minus 1 comma 1. R is equal to root of minus 1 whole square is 1 plus 1. Minus 1 whole square plus 1 square. Root of 1 plus 1 is root 2. So R will be equal to root 2. And you come to theta. So what is theta? First step, you forget the signs. Try to get an allied position in the first quadrant. So theta is equal to tan inverse of modulus of y is 1. Modulus of x is also 1. So that is equal to tan inverse of 1 is pi by 4. Now, in the second stage, go to the signs of the coordinates. The x coordinate is negative, y coordinate is positive. That means the angle is in the second quadrant. So in the second quadrant, what is the allied angle to pi by 4? So in the second quadrant, you have pi minus pi by 4. That is 3 pi by 4 will be the angle. So that will be the theta. Next, if you go to the third question, again r is equal to root of x coordinate square plus y coordinate square. So 12 plus 4 is equal to root 16, 4. So r is equal to 4. And theta is equal to tan inverse of modulus of y by modulus of x, 2 by 2 root 3. That is equal to pi by 6. So pi by 6 is the allied position to theta in the first quadrant. Now go to the signs of the coordinates, minus and minus. X coordinate is negative, y coordinate is negative. So you want an angle in the third quadrant. So what is the allied angle to pi by 6 in the third quadrant? If you draw the coordinate system, this is pi by 6. The allied position is pi plus pi by 6. That is pi plus pi by 6. That is 4 comma 7 pi by 6 is the answer. Next, let us go to the last example. So 1 comma minus root 3. So r is again equal to root of 1 square plus minus root 3 whole square. 1 plus 3 is equal to 4. Root 4 is equal to 2. So r is equal to 2. Now, let's go for theta. Again, in the first step, forget about the signs. So theta is equal to tan inverse of modulus of y by modulus of x. It is root 3 by 1. So tan inverse of root 3 is equal to pi by 3. Pi by 3. This is not the theta here. Now this is the first step. You got an angle in the first quadrant which is allied to the angle which is the answer. Now go to the point and see the quadrant in which the point lies. X coordinate is positive, y coordinate is negative. It means the point lies in the fourth quadrant. So what is the allied position to pi by 3 in the fourth quadrant? Minus pi by 3. So the corresponding polar coordinates are 2 comma minus pi by 3. So this is how you find the polar coordinates. The important thing that you need to understand is the polar coordinates are not unique. So 6 comma pi by 3 can be written as 6 comma any number of 2 pi's plus pi by 3. All these points correspond to the same Cartesian coordinate 3 comma 3 root 3. Similarly, root 2 comma 2n pi plus 3 pi by 4 all these coordinates represents the same point -1, 1. So I hope you have understood what I'm doing. So if you have a particular theta, any number of 2n pi's can be added to the angle. The position of ray remains same. The position of ray does not change. Hence, the point does not change. So now I hope you have understood what polar coordinates are and how to convert from one type of coordinates to another type of coordinates. In this video, let us look at the topic of oblique axis. If x and y axis are inclined at some angle other than 90 degrees to each other, they are called oblique axis. For example, they are inclined at an angle of theta with each other, where theta is not equal to 90 degrees. Now, how do we measure the x coordinate and y coordinate of different points in different quadrants using oblique axis? We use the same definition for x coordinate and y coordinate. For example, if you have a point P, so the x coordinate of this point P is the distance from y axis measured in the direction of x axis. That is, you have to measure the distance of P from y axis in a direction which is parallel to x axis. That is, you have to go in the direction of x. Whatever is the distance is the x coordinate. Similarly, if you want the y coordinate, you should not go perpendicular to x axis. Y coordinate is the distance of this point P from x axis in a direction which is parallel to y axis. So you have to go in the direction which is along the y axis. So this distance is nothing but y. So in the rectangular coordinate system, that is, if the angle between x axis and y axis is 90 degrees, this figure will be a rectangle. But in the oblique coordinate system, the figure that is formed with the coordinate axis and with the distances of xy from different axes will be a parallelogram. So that's the only difference between the rectangular axis. That is, when the angle is 90 degrees between x and y axis, we can call them rectangular coordinate axis. So in the rectangular, that's the only difference between the oblique axis and the rectangular axis. If you understand that distances will be measured in the direction parallel to x axis and y axis, you can analyze the questions very easily in this coordinate system also. In this video, let us look at distance formula. That is, how do we find the distance between two given points? For example, if you take the point P, let us say that the coordinates of point P are x1 and y1 and the coordinates of Q are x2 and y2. Suppose that these two are given. That means all the four numbers are given. So can you find the distance between these 2 points? So as you can see, let me plot these 2 points on the coordinate system. So how do we find the distance d between these 2 points? So whenever you need to find distance, the most straightforward method is to see whether you can form a right angle triangle or not. So you can form infinite right angle triangles about this hypotenuse, but I'll draw a right angle triangle which is whose sides are oriented around the x and y axis. So the construction is that I draw a right angle triangle whose sides are along x axis and y axis. That is, this is parallel to x axis, this is parallel to y axis. So let us say that the foot of the perpendicular of P on x axis is m. Let us say that the foot of the perpendicular from Q on x axis be n. And let us say that the foot of the perpendicular of P onto Qn is r. So now this is the construction that we do. Now as you can see, triangle PQR is a right angle triangle. So triangle PQR is a right triangle. Hence, d square can be written as PR square plus QR square, right? D square can be written as PR square plus QR square. Now the question is, what is the lengths PR and QR? Can I find them in terms of the given coordinates? Yes. Now as you can see, what is OM? OM is nothing but the distance of P from y-axis, which is the x1. And what is ON? ON is nothing but the distance of point Q from y-axis, which is x2. So what is MN? MN is x2 minus x1. This is x2, this is x1. So this is x2 minus x1. So if this is x2 minus x1, PR is also equal to x2 minus x1, right? Now similarly, so what is this distance PM? PM is nothing but y1, right? That is the distance of point P from x-axis. So if this is y1, Rn is also equal to y1. Now, what is the distance Qn? Qn is equal to y2. That is the distance of Q from x-axis. This is y2. Now this is y2, this is y1. So RQ is y2 minus y1, right? So this is x2 minus x1, this is y2 minus y1. So d square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. That is the difference between the x coordinates whole square plus difference between the y coordinates whole square. So d square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. This implies d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is a very important formula and the most basic formula in your coordinate geometry. How do you find the distance between 2 points? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. And in a special case, if one of the point becomes origin, so if distance of point P x comma y from origin is a special case. Instead of the second point, you want the distance of P from origin is equal to d is equal to root of, obviously we know that the coordinates of origin are 0, 0. So one of the coordinates will become 0, 0. The other coordinate we have set it as x comma y. So x minus 0, which is x, y minus 0, which is y. So square root of x square plus y square. So these are the two formulas which you need to remember. So if you have two different points, root of x2 minus x1 whole square plus y2 minus y1 whole square. And if you have one given point and the other point is origin, the distance is root of x square plus y square directly. So this is how you find the distance between the coordinates if the coordinates are given in a rectangular Cartesian system. Now you also saw that the coordinates can be given in polar coordinates or with respect to oblique axis. This formula will not be valid in those cases. So let us see how to find the distance if the coordinates are given in polar coordinates and if the axes are inclined to each other at an angle other than 90 degrees. So let us say that you're given two coordinates, 2 points P and Q, whose coordinates are given in polar coordinates. That is, let P be r1 theta 1, let Q be r2 theta 2. Now what is the meaning of r1 and theta 1? We have already seen this. So this distance OP is r1 and this angle is theta 1. And what is OQ? The length OQ is r2 and this angle is theta 2. The angle made from x-axis and up to this ray is theta 2. Now what is the angle between these two rays? So this small angle is theta 1, this complete angle is theta 2. So the angle between these two rays is obviously theta 2 minus theta 1. So theta 2 minus theta 1. Now you're asked to find the distance between P and Q. So this can be found out using cosine rule for triangles. So from cosine rule for triangles, d square will be equal to r1 square plus r2 square minus 2r1 r2 times cos of angle between these two sides, cos of theta 2 minus theta 1. So this implies d is equal to square root of r1 square plus r2 square minus 2r1 r2 cos of theta 2 minus theta 1. So this is how you find the distance if the coordinates are given in polar system. So now instead of rectangular coordinate axis, if you have axis inclined at an angle of theta with each other, in this coordinate system if you are given 2 points x1 y1 and x2 y2, how do you find the distance between these 2 points? Again we use the same cosine rule for triangles. So as you can see, if you have 2 points PQ, instead of drawing perpendiculars now, draw lines parallel to x-axis and y-axis. So as you know, this length is nothing but y1, this whole length is nothing but y2. So if you put these points as M, N and R, so QR will be equal to y2 minus y1. Similarly, if you want PR, so as you know, this length is nothing but x1, this complete length is nothing but x2. So Mn is equal to x2 minus x1. So PR is also equal to x2 minus x1. Now, as you know, if this distance is theta, this distance is also equal to theta. This distance is 180 minus theta because this is a parallelogram. So if this is 180 minus theta, this angle is also equal to 180 minus theta. So if this angle is theta, this angle will be 180 minus theta. So now using the cosine rule, d square is equal to x2 minus x1 whole square plus y2 minus y1 whole square minus 2 times x2 minus x1 times y2 minus y1 into cos of the angle between these two sides, 180 minus theta. So this implies d is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square minus 2 times x2 minus x1 times y2 minus y1 times cos 180 minus theta, as we have learned in trigonometry, is minus cos theta. So you get an extra minus from this. So this minus will become plus cos of theta. So this will be the distance formula for oblique axis. If theta is equal to 90 degrees, cos 90 will become 0. So this term completely disappears. So you get the original distance formula. So this will be the formula which needs to be used for oblique axis. Root of x2 minus x1 whole square plus y2 minus y1 whole square plus 2 times x2 minus x1 times y2 minus y1 cos theta. So I hope you have understood all the 3 different systems and how to find distance between 2 given points. Now let us try to see where this distance formula can be used. What are the different situations in which you can use distance formula? In this topic, we are going to look at the uses of distance formula. So what are the different situations in which we can use distance formula to solve our questions? So the first important situation is if you are given 3 points A, B, C. If you are given the coordinates of 3 points A, B, C, using distance formula, we can check whether these 3 points are collinear or not. So collinearity of 3 points. Collinearity of 3 points. If the coordinates of 3 points are given, we can check whether the 3 points are collinear or not using distance formula. So how do we do this? If the 3 points are collinear, then sum of any 2 distances, you need to find all the 3 distances, distance AB, distance BC and distance AC. If sum of 2 distances is equal to the third distance, then the 3 points are collinear. If not, they are not collinear. So very easily by finding the distances, you can check whether the 3 points are collinear or not. I hope this is very clear. The second use is if the points A, B, C are not collinear, if the points A, B, C are not collinear, obviously they form a triangle. So you can determine the nature of triangle. You can determine what kind of triangle ABC forms. For example, is it an equilateral triangle? Is it an isosceles triangle? Is it a scalene triangle? So you can determine whether it is an equilateral triangle, isosceles or scalene just by finding the distances. You find all the 3 distances. If all the 3 distances are equal, then it is an equilateral triangle. If only 2 sides are equal and the other side is not equal, then it is an isosceles triangle. So if all the 3 sides are different, then it is a scalene triangle. You can also determine whether it is a right angle triangle or not. You can also determine whether it is a right triangle. If the largest side square is equal to the sum of squares of other 2 sides, then it is a right angle triangle. Or you can also determine whether it is a right isosceles triangle. Right isosceles triangle, right? So if the condition for right angle triangle, Pythagoras theorem, is also valid, as well as if 2 sides are equal, then it becomes a right angled isosceles triangle. So using the distance formula, if you're given 3 points, we can determine what kind of triangle the points form. Next, if you're given 4 points A, B, C, D, if you're given 4 points, you can determine the nature of quadrilateral. You can determine the nature of quadrilateral that is formed. If you are given 4 points A, B, C, D, you can determine whether A, B, C, D forms a parallelogram or a rhombus or a rectangle or a square using just distance formula. So you just need to find 6 distances to determine which figure the 4 points form. So you need to find the lengths AB, BC, CD and DA. These are the sides, and AC, BD, AC and BD, which are the diagonals. So if you find these 6 lengths, you can very easily determine which kind of quadrilateral the 4 points form. So first, if the opposite sides are equal, if AB is equal to CD and BC is equal to DA, and the diagonals are not equal. First, suppose that the diagonals are not equal. The pair of opposite sides are equal and the diagonals are not equal implies a parallelogram. Next, if opposite sides are equal and the diagonals are also equal, if AB is equal to CD and BC is equal to DA, if opposite sides are equal as well as the diagonals are equal, then the figure becomes a rectangle. If all the sides are equal, if AB is equal to BC is equal to CD is equal to DA and the diagonals are not equal, then becomes a rhombus. And the final figure, if all the sides are equal and the diagonals are also equal, the figure formed will be a square. So this is how you check whether the figure is a parallelogram or a rectangle or a rhombus or a square. So you need to find 6 lengths. From these 6 lengths, we can determine the nature of quadrilateral. We can see whether the quadrilateral is in any way special. So as you have to understand, if the quadrilateral is a square, it automatically becomes a parallelogram. So as we go down, the strictness of the figure increases. So if it is a rectangle, it is already a parallelogram. If it is a rhombus, it is already a parallelogram. If it is a square, it is a parallelogram as well as a rectangle as well as a rhombus. So these are the specific conditions for parallelogram, rectangle, so on. So these are the 3 major uses of distance formula: to check the collinearity, to find the nature of the triangle, to find the nature of the quadrilateral. So in the first example, you're asked to find the distance between these points. So nothing is given about the angle between the coordinate axis. So in a default case, we take the axis as rectangular coordinate axis. So x1, y1 and x2, y2 are given. So the distance between the points is root of x2 minus x1. You can take any point as x1, y1, any point as x2, y2. Doesn't really matter. It's not necessary that the first one has to be taken as x1, y1. The second is taken as x2, y2. So you can take them in any order. So let these be x2, y2. So let these coordinates be x1, y1. So x2 is 5, y2 is 6, x1 is 2, y1 is 3. So x2 minus x1, 5 minus 2. So 5 minus 2 whole square plus y2 minus y1, 6 minus 3 whole square. That is equal to root of 5 minus 2 is 3, 3 square, 9 plus 6 minus 3 is also equal to 3, 3 square is 9, root 18 is nothing but 3 root 2. Now let us go to the next question. So the distance is equal to root of, again, x2 minus x1, 5 minus of minus 2. So you have to take the sign into consideration. So and use the exact same formula, x2 minus x1, 5 minus of minus 2 whole square, that is 5 plus 2 whole square, plus y2 minus y1, minus 3 minus 5. So minus 3 minus 5 whole square. That is equal to root of 5 plus 2 is 7, square is 49, 5, 3 minus 5 minus 3 is minus 8, whole square is 64. That is equal to 113, root of 113. So that will be the distance between these 2 points. Next, let us take these 2 points. Distance is equal to root of x2 minus x1 minus 5 minus of minus 1 is plus 1. So minus 5 plus 1 whole square plus y2 minus y1 minus 7 minus of minus 3 is plus 3 whole square. So minus 5 plus 1 is minus 4 whole square is minus 4 whole square is 16. Minus 7 plus 3 is also equal to minus 4 whole square is 16. That is equal to root 32 is 4 root 2. Next, if you have these 2 points, distance is equal to root of minus 3 minus 1 minus 4 whole square plus 4 minus of minus 2 is plus 2. So 4 plus 2 is 6 square. That is equal to root of 16 plus 36 is equal to root of 52. Root of 52. So you can take 2 outside. This is 4 into 13. So this is 2 root 13. So this is how you find the distance between 2 points. So you have to use the formula along with the signs of the given numbers. You should not change the signs by yourself. You apply the exact same formula, you get the right answers. In this question, you're given that the point P is x comma 2. There is an unknown in the coordinate of the point. So point P is x2, point Q is 3, 4. And the distance between these 2 points is given to you. If that is so, can you find the value of x? So let us first directly analyze this question with respect to the formula, and then we'll analyze this question geometrically. So first we know that the distance d is equal to root of x2 minus x1 whole square, that is 3 minus x whole square plus 4 minus 2 whole square. This implies if you square it on both sides, the distance is given as 2. So 2 square 4 is equal to 3 minus x whole square plus 4 minus 2 whole square is 2 square, which is equal to 4. This implies 3 minus x whole square is equal to 0. This implies 3 minus x is also equal to 0. This implies x has to be equal to 3. X has to be equal to 3. So this is the answer to this question. Now if you try to analyze this question geometrically, so you take the coordinate axis. So one point is 3, 4. So one point is 3, 4. And the next point is that the x coordinate is unknown here, but the y coordinate is equal to 2. So as you know, if you take any point on this horizontal line, y coordinate 2 means the distance of the point P from x-axis is 2. So what is the what is the locus of points which are at a distance of 2 units from x-axis? You get a parallel line. So my P can be any point on this line. Any point on this line has y coordinate as 2. So right now the x coordinate is unknown. I want the distance between PQ as equal to 2 units. So what I try to do is I want a point P on this line which is at a distance of 2 units from this point Q. So what you just need to do is you just need to draw a circle of radius 2 about the point 3, 4. As you can very clearly see, this distance is equal to 2, right? This distance is equal to 2. If you draw a circle of radius 2, so the circle will look something like this. Circle will look something like this. So as you can very clearly see, this circle is intersecting this line at the point, at the exact point. So the y coordinate is equal to 2. The x coordinate will be exactly same as the x coordinate of this point because going vertically downwards. only the y coordinate decreases, x coordinate remains same. So you get x as equal to 3. So do you see the relation between geometrical interpretation and formula interpretation? So if the distance is equal to 3 instead of 2, you just need to draw a circle with radius 3 units. If you draw a circle with radius 3 units, it starts from here. So you get a circle like this. So as you can very clearly see, you get two answers now. There are 2 points on this line which are at a distance of 3 units from this point. So you get 2 points, not just 1 point. If you solve for d is equal to 3, so let us see what happens. If d is equal to 3, on squaring you get 9 is equal to 3 minus x whole square plus 4. So 3 minus x whole square is equal to 5. This implies 3 minus x is equal to plus or minus root 5. So x is equal to 3 minus or plus root 5. So the value of x can be 3 minus root 5 or 3 plus root 5. So for different distances, you might get one answer or more than one answers. In this question, you are given 2 points, minus 3, minus 2, minus 6, 7. You are asked to find the distance between these 2 points where axes are inclined at 60 degrees to each other. It means we are talking about oblique axis. What is the distance between these 2 points if the axes are inclined at 60 degrees to each other? So let us directly use the formula that we have. So this is x1, this is y1, so this is x2, y2. So distance is equal to square root of x2 minus x1 whole square minus 6 plus 3 whole square plus y2 minus y1 whole square. 7 minus of minus 2 is plus 2 whole square. x2 minus x1 whole square plus y2 minus y1 whole square plus 2 times x1 minus x2 times y1 minus y2 times cos of angle between the axes, that is cos of 60 degrees. That is equal to square root of minus 6 plus 3 is minus 3, whole square is 9, plus 7 plus 2 is 9, 9 square is 81, plus 2 times minus 3 times 9. So 2 times minus 3 times 9, cos 60 is 1 by 2. So this 2 and 2 gets cancelled. So root of, this is 81 plus 9 is 90 minus 27. 90 minus 27 is 63. So root 63 is the distance between these 2 points. Root 63 is 7 into 9. So if you take 3 outside, you get 3 root 7 as the answer. In this question, you're given the polar coordinates of 2 points. R1 is 2, theta 1 is 60 degrees. R2 is 5, theta 2 is 270 degrees. So you're asked to find the distance between these 2 points. So let us use the direct formula. D is equal to root of R1 square, that is 4, plus R2 square, 25, plus, so root of R1 square plus R2 square, minus 2 times R1 is 2 into R2 is 5 minus 2 R1 R2 into cos of theta 1 minus theta 2. That is 270 minus 60. 270 minus 60. So 210 degrees. So cos 210. 210 can be written as 180 degrees plus 30 degrees. So 210 is in the third quadrant. So cos is negative. So this is minus cos 30. That is equal to root of 29 minus 5 2s are 10, 10 2s are 20 times this is minus cos 30. It is minus root 3 by 2. So that is equal to root of 29 plus 10 root 3. So this will be the distance between these 2 points. In this question, you're given 3 points, 1, 1, minus 2, 7 and 3, minus 3. You're asked to find the nature of these 3 points. That is, you have to check whether these 3 are collinear or not. And if they are not collinear, what kind of triangle are they forming? So first, let us check the collinearity of these 3 points. To check the collinearity using distance formula, we need all the 3 distances, that is AB, BC and AC. So what is AB? AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So minus 2 minus 1, it is minus 3 whole square plus 7 minus 1 is 6 whole square. That is equal to root of 9 plus 36, square root of 45. And next, what is the length of BC? BC is equal to root of, again, x2 minus x1 whole square. 3 minus of minus 2 is plus 2. So 3 plus 2 is 5 square plus minus 3 minus 7 minus 10 whole square. That is same as plus 10 whole square. That is equal to root of 100 plus 25 is 125. So what is the length of CA? Again, root of x2 minus x1 whole square. 3 minus 1 is 2. So 2 square plus minus 3 minus 1 is minus 4. Minus 4 whole square. That is equal to root of 4 plus 16 is root of 20. So as you can very clearly see, this is the largest side. So now let us try to see if the largest side is sum of the other 2 sides or not. So root 45 can be written as 3 root 5, right? Because this is 9 5s are 45. So 9 comes out of the square root as 3. So 125 is nothing but 5 root 5. This is 25 into 5. So 5 comes out. Root 20 is 2 root 5. That is 4 into 5. So 2 root 5. So as you can very clearly see, BC is equal to AB plus AC. BC is equal to AB plus AC. AB plus AC. So 5 root 5 is equal to 3 root 5 plus 2 root 5. Hence, A comma B comma C are collinear. That's the conclusion. So as you can see, if you have B here, C here, A here, BC is equal to AB plus AC. Hence, the 3 points are collinear. That's the conclusion. In this question, again you're given 3 points. You're asked to find the nature of the triangle. So again, let us find the sides of this triangle and check what the nature is. So what is the length of PQ? PQ is equal to root of 3 minus of minus 2, that is 3 plus 2 whole square, minus 2 minus 3, that is plus minus 5 whole square. That is equal to root of 25 plus 25 is root 50. Or this can be written as 5 root 2. So what is QC? QC is again root of 3 minus 0 whole square plus minus 2 minus 0 whole square. It is 3 square plus 2 square. That is root of 13. And what is PC? PC is equal to root of 2 minus 0 whole square plus 3 minus 0 whole square. Again, 2 square plus 3 square is equal to root of 13. So 2 sides are equal and the third side is different. And you can very clearly see that PQ square is not equal to PC square plus QC square. So I'm also checking for right angleness. So Pythagoras theorem is not valid because QC square plus PC square is 26, but PQ square is 50. So this is an isosceles triangle. So these 3 points form an isosceles triangle. In this question, you're given 4 points. You're asked to find what kind of quadrilateral these 4 vertices form. So as we have seen in the theory, to find the nature of quadrilateral, we need to find 6 distances. That is the lengths of sides and the lengths of diagonals. So let us try to find the lengths of sides. AB is equal to root of. By now you would be comfortable with distance formula. So I'll try to do the numbers directly. So AB is equal to root of 3 minus 1, that is 2 square, plus 6 minus of minus 2 is 8. 8 square. That is equal to root of 64 plus 4 is 68. What is BC? Root of 5 minus 3 whole square, 4 plus 10 minus 6 whole square, 16. That is equal to root of 20. What is CD? Root of 3 minus 5 whole square plus 2 minus 10 whole square, that is 8 square. Again root of 68. What is DA? Root of 3 minus 1 whole square plus 2 plus 2 whole square is equal to root 20. For now, the pair of opposite sides are equal. Now let us go to the diagonals also. AC is equal to root of 5 minus 1 whole square plus 10 plus 2 whole square. That is 12 square is 144. So root of 160. And what is CD? Is equal to root of 3 minus 3 whole square is 0. 0 square plus 6 minus 2 whole square is 16. That is equal to 4. So as you can see, AB is equal to CD and BC is equal to DA. The opposite sides are equal and diagonals are not equal. Hence, the figure is a parallelogram. So ABCD is a parallelogram. That's the answer to this question. In this video, let us look at the topic of section formula. So now what do we deal in this topic? So assume that you have 2 points A and B. A is the point x1, y1, B is the point x2, y2. So let us join x1 and y1. So you get the line segment x1, y1, x2, y2. Now I want the point P on this line segment which divides AB in the ratio m:n. If I want certain point on this line segment AB which divides AB in a given ratio m:n, then what is the coordinates of the point? So what are the coordinates of this point? So that's the question that we are going to deal in this topic. So this point is said to divide AB in the ratio m:n internally. So the formula is PH comma K. The point which divides AB in the ratio m:n internally is simply, so you have 2 coordinates, right? You have 2 coordinates, x coordinate and the y coordinate. So x coordinate involves only the x coordinates of the points. Y coordinate of P involves only the y coordinates. So the x coordinate is given by m times x2 plus n times x1 by m plus n. So you need to remember it as cross multiplication. So this number has to be multiplied with this x coordinate. This number has to be multiplied by this x coordinate. So m times x2 plus n times x1 by m plus n. So the x coordinate of P involves only the x coordinates of the points A and B. Now if you want the y coordinate, so K is equal to m times y2 plus n times y1 by m plus n. M y2 plus n y1 by m plus n. So this gives you the point which divides AB in the ratio m:n internally. There is another kind of division called external division. So if you join A and B, a point on the extended line AB, such that the length of AP by the length of BP is equal to m by n is said to divide AB externally in the ratio m:n. So AP by PB is equal to m by n. Here also AP by PB is equal to m by n. But here P lies within AB, here P lies outside AB. So let us call this P dash. So P dash h comma k is given by mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. So this is the formula for internal division. This is the formula for external division. So you just need to replace pluses with minuses both in the numerator and denominator. So you need to remember these two formulas. So let us derive these formulas now. So for example, let us consider 2 points AB. A is 1, 2, B is 4, 1. Now I want a point P h comma k which divides AB in the ratio 1:2 internally. 1:2 internally. That means I want a point P inside the line segment AB such that AP by PB is equal to 1 by 2, right? So the distance AP by the distance PB is 1:2. So how do I get this? From the formula of internal division. So P is given by, so this ratio is 1:2. So 1 times 4, you have to do the cross multiplication. So remember that the x coordinate of P involves only the x coordinates. The y coordinate of P involves only the y coordinates. So what is the x coordinate of P? 1 into 4 m into x2 plus n times x1 2 times 1 by m plus n is 1 plus 2. What is the y coordinate? The y coordinate of P involves only the y coordinates of A and B. So 1 times 1 plus 2 times 2 by m plus n again. That is equal to 4 plus 2 is 6 by 3 is 2. 1 plus 4 is 5 by 3. So the point P is given by 2, 5 by 3. So those are the coordinates of the point P. Now, next, if I want a point P dash which divides AB in the ratio 1:2 externally. That means again I want a point on this line AB such that AP by PB is equal to 1 by 2 again. But P should not lie inside the line segment AB. So this time if I want a point P dash which satisfies this relation, where do you think P dash has to lie? So will P dash lie here or here? So as you can see, if P dash lies here, AP dash will always be more than BP dash. But I want AP dash to be less than BP dash. So obviously P dash cannot lie on this side. So P dash will lie somewhere here, such that AP dash is one part, P dash B is 2 parts. So P dash will lie on the side of AB, on the side of A. So what are the coordinates of P dash again? So let us use the formula. In the formula, instead of plus, have a minus sign. That's the only difference. So again, the formula is mx2 minus nx1 by m minus n. 1 into 4 minus 2 into 1 by 1 minus 2. In the numerator as well as denominator, you get a minus. And 1 into 1 minus 2 into 2 by 1 minus 2. That is equal to 4 minus 2 is 2 by minus 1. That is minus 2. And 1 minus 4 is minus 3 by minus 1 is plus 3. So 4 minus 2, 2 by minus 1 is minus 2. 1 minus 4 is minus 3 by minus 1 is 3. So minus 2 comma 3 is the point P dash which divides AB in the ratio 1:2 externally. So I hope this example is clear. In this topic, let us look at some very important points that needs to be remembered in section formula. So the first important point that you need to remember is that every ratio of the form m:n can be expressed as m by n is to 1. m:n is same as m by n is to 1, which is of the form lambda is to 1. So every ratio m:n can be assumed as lambda is to 1, where lambda is nothing but m by n. For example, assume that you are given 2 points A 1, 2 and B 4, 5. 1, 2 and 4, 5. Let us say that P is the point 2, 3. Now you are asked to find what the ratio in which P divides AB. So how do you get this? This is not a single stage question. So first, the ratio is unknown here. So if you know the ratio, you can find the point directly by the formula. Now given the point, you are asked to find the ratio in which this gets divided. So there are two ways. You can assume that the ratio is m by n. You can assume that the ratio is m:n or lambda is to 1. So if you assume the ratio to be m by n, the working will be 2, 3. This point is equal to m into 4, that is 4m plus 1 into n by m plus n, 5m plus 2n by m plus n. So if you assume that the ratio be m:n, this will be the corresponding condition. If you assume that the ratio is lambda is to 1, then 2, 3 will be equal to 4 lambda plus 1 by lambda plus 1, 5 lambda plus 2 by lambda plus 1. So here, if these two ordered pairs are equal, x coordinate has to be equal to x coordinate, y coordinate has to be equal to y coordinate. So 2 is equal to 4m plus n by m plus n. 3 is equal to 5m plus 2n by m plus n. And you're required to find the ratio of m:n. You're required to find the ratio of m and n. This implies 2m plus 2n is equal to 4m plus n. This implies 2m is equal to n, right? If 2m goes onto that side, 4m minus 2m is 2m. 2m minus n is n. This implies m by n is equal to 1 by 2. m by n is 1 by 2. This implies the ratio is 1:2. So this is one way of trying to solve this question. Now, take the second condition. From one condition you got the value of m by n. Now the second condition is 3m plus 3n is equal to 5m plus 2n. This implies 5m minus 3m is 2m, 3n minus 2n is n. This implies m by n is equal to 1 by 2 again. So if you get the same m is to n from the x coordinates as well as the y coordinates, that means this point actually lies on the line segment AB. If you get one ratio from the x coordinates and the other ratio from y coordinates, that means the point does not lie on this line. So if the point lies on this line, the ratio with respect to x coordinates will be exactly same as the ratio with respect to y coordinates. Now instead of this process, if you assume the ratio to be lambda is to 1, the working is like this. 2 is equal to 4 lambda plus 1 by lambda plus 1. 2 lambda plus 2 is equal to 4 lambda plus 1. 2 lambda is equal to 1 and lambda is equal to 1 by 2. That means the ratio is 1 by 2 is to 1, which is exactly same as 1 is to 2. So this is a slightly better process where you have only one unknown instead of two unknowns. Now if you take the second condition, if you get the same lambda 1 by 2 from the next equation also, that means the point lies on the line segment AB. If lambda turns out to be different than half from this equation, that means the point P does not lie on the line segment AB. Now there is a slight simplification that you need to understand here. If you are just asked to find the ratio, the simplest method is just consider the x coordinates. If you have x1, x2, x3, x1, x2, x3, then the ratio in which the point divides AB is nothing but x1 minus x2 is to x2 minus x3. This minus this is to this minus this. x1 minus x2 is to x2 minus x3. So you can clearly check this. 1 minus 2 is minus 1 is to 2 minus 4 is minus 2. So you get the same ratio 1 is to 2. Similarly, if this point lies on this line segment, y coordinates also should be in the same ratio. So 2 minus 3 is minus 1 is to 3 minus 5 is minus 2. Again the ratio is 1 is to 2. So this is a shortcut which you need to understand if you want to find the ratio in which the cutting happens. So what's the first point? M is to n ratio can be assumed as lambda is to 1. You get the same answers. The next point is that negative ratios means external division. External division. For example, if you're given 2 points AB, one is 1, 2 and the other is 4, 5. Now you're given a third point which is 7, 8. You're given a third point which is 7, 8. You're asked to find the ratio in which C divides AB. The ratio in which C divides AB. So initially we assume that the ratio is lambda is to 1. The ratio is lambda is to 1. So 7, 8 is equal to 4 lambda plus 1 by lambda plus 1 and 5 lambda plus 2 by lambda plus 1. So we equate the x coordinates, we equate the y coordinates. So 7 is equal to 4 lambda plus 1 by lambda plus 1. So 7 lambda plus 7 is equal to 4 lambda plus 1. 3 lambda is equal to minus 6. 3 lambda is equal to minus 6. So lambda is equal to minus 2. From the y coordinates, 8 lambda plus 8 is equal to 5 lambda plus 2. 3 lambda is equal to minus 6. Lambda is again equal to minus 2. So from both x coordinates and y coordinates, you're getting the same value of lambda. So what is the ratio? So the ratio is lambda is to 1, that is minus 2 is to 1. So what is the meaning of minus 2 is to 1? What is the meaning of negative ratio? So negative ratio means external division. That means C divides AB externally in the ratio 2:1. So when you don't write externally, you have to include a minus, and minus means external. Once you write external, again you don't need to write minus. So C divides AB externally in the ratio 2:1, or directly C divides AB in the ratio -2:1. So whenever you see a negative ratio, you need to understand that the ratio is an external division. So I hope you understood this point. This is a very important point that you need to understand. Otherwise, if you don't know the meaning of negative ratios, you get confused. So negative ratios means external division. Now the third point is the ratio in which the line segment joining x1, y1 and x2, y2 is divided by x-axis. So ratio in which AB formed by x1, y1 and x2, y2 is divided by x-axis is nothing but minus of y1 by y2, and the ratio in which AB is divided by y-axis is nothing but minus of x1 by x2. So these are the two ratios which you can directly remember. The logic is very simple. If you have a point on x-axis, the point will be of the form x, 0. Point will be of the form x, 0. So the division ratio can be very easily found out using the y coordinates. So the ratio lambda is to 1 is nothing but y1 minus 0, because we have already seen that the ratio can directly be obtained by just taking the differences. So y1 minus 0 divided by 0 minus y2, that is nothing but minus of y1 by y2. So the ratio in which x-axis divides AB, x-axis divides AB is minus of y coordinate of this by y coordinate of this. Similarly, the ratio in which y-axis divides AB is nothing but minus of x1 is to x2, because the point Q on y-axis looks like 0, y. So you can calculate the ratio using the x coordinates, x1 minus 0 by 0 minus x2. That is minus of x1 by x2. So the next point is that if you have a line segment AB, x1, y1 and x2, y2, the midpoint of AB, is given by x1 plus x2 by 2 and y1 plus y2 by 2. So the midpoint of AB is x1 plus x2 by 2 and y1 plus y2 by 2, because the ratio is just 1:1. So mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. So you have the exact application. So midpoint of AB, which is also called midpoint formula, is x1 plus x2 by 2, y1 plus y2 by 2. And next, if you want the points of trisection, that is the points which divide AB into 3 equal parts. So you get one point here, another point somewhere here. So these are the points of trisection. You can very easily see that the points of trisection divides AB in the ratio 1:2 and 2:1. So what are the points? You get 2x1 plus x2 by 3, 2y1 plus y2 by 3 is the one point of trisection, and x1 plus 2x2 by 3, y1 plus 2y2 by 3. This is the second point of trisection. So these are the 2 points of trisection that you have for line segment AB. In this video, let us look at how to determine whether 3 points are collinear using section formula and how to determine the nature of a quadrilateral using section formula. So if you are given 3 points A, B, C, so how can you determine using section formula that these 3 points are collinear? So the simple trick is we assume that the point B divides AC in the ratio lambda is to 1. So lambda is to 1. So let us take this as x1 y1, this as x2 y2, this as x3 y3. So x2 y2 will be equal to lambda x3 plus x1 by lambda plus 1, lambda y3 plus y1 by lambda plus 1. So x2 y2 is equated to this. So from the first equation you get some value of lambda, from the second equation you get another value of lambda. If these two values of lambda are equal, that means that B divides AB in certain ratio. If lambda from x coordinates is different from lambda from y coordinates, that means this point does not divide AB in any particular ratio. That means B lies outside AC. So if you get the same values of lambda from the first equation and the second equation, that means A, B, C are collinear. If you get different values of lambda from these two equations, that means that B lies outside the line segment AC and B, A, C are non-collinear. Next, if you are asked to find the nature of the quadrilateral formed by 4 points A, B, C, D, by 4 points A, B, C, D. So we have already seen how to use distance formula to determine the nature of quadrilateral. Now let us see how to use section formula. So the first condition is if diagonals bisect each other, that means you find the midpoint of AC and the midpoint of BD. The midpoint of AC from the midpoint formula, the midpoint of BD from the midpoint formula. If you get the same point, if diagonals bisect each other, then it will compulsorily be a parallelogram. If diagonals bisect each other, it will automatically become a parallelogram. You don't need to check anything else. If in a quadrilateral diagonals bisect each other, it certainly becomes a parallelogram. Next, the more additional conditions that get satisfied, the more specific the figure becomes. So diagonals bisect each other, diagonals bisect each other and the length of diagonals is also equal. That means it becomes a rectangle. Now diagonals bisect each other. If AC is not equal to BD, that means the diagonals are not equal, but adjacent sides are equal. AB is equal to AD. This becomes a rhombus. The figure becomes a rhombus. Next, diagonals bisect each other. The diagonals are also equal. Diagonals bisect each other, diagonals are equal, and the adjacent sides are also equal. This becomes a square. So as you go down, the figure becomes more and more specific. If all the three conditions are valid, then it is a square. If diagonals bisect each other, the adjacent sides are equal but diagonals are not equal, then it is a rhombus. If diagonals bisect each other and diagonals are equal but the adjacent sides are not equal, then it is a rectangle. If adjacent sides are equal, it becomes a square. If just diagonals bisect each other and no other conditions are satisfied, that is, diagonals are also not equal, adjacent sides are also not equal, it means the figure is just a parallelogram. So this is how you categorize the nature of quadrilateral using section formula as well as distance formulas. In this question, you're asked to prove that these four vertices form a parallelogram, and you're also asked to check whether it becomes a rectangle or not. So again, a very straightforward question. Let us say that the vertices are A, B, C, D. Now, how do we determine whether it forms a parallelogram or not? Just by seeing whether diagonals bisect each other or not. So what is the midpoint of AC? The midpoint of AC is -2 plus 4 by 2 minus 1 plus 3 by 2. That is equal to -2 plus 4 is 2 by 2 is 1. Minus 1 plus 3 is 2 by 2 is 1. 1 comma 1. What is the midpoint of BD? So 1 plus 1 by 2, 0 plus 2 by 2. That is equal to 1 comma 1. So the midpoint of AC is same as the midpoint of BD. That means diagonals bisect each other. So if you take the figure, it looks something like this: A, B, C, D. We have seen that the midpoint of AC and the midpoint of BD is same. Hence, A, B, C, D is a parallelogram. There's no doubt about it. Now, you're also asked to check whether it becomes a rectangle, whether it becomes more specific. So when will a parallelogram become a rectangle? If the diagonals are equal. So to see whether it is a rectangle or not, we have to measure the lengths of the diagonals also. So what is AC? Root of 4 plus 2 whole square plus 3 plus 1 whole square. Root of 6 square plus 4 square, that is equal to root of 36 plus 14 is root 50. And what is BD? BD is nothing but root of 1 minus 1 whole square plus 2 minus 0 whole square, that is equal to root 4, which is equal to 2. So AC and BD are not equal. This implies ABCD is not a rectangle. Not a rectangle. In this question, you're given 2 points, A 2, 1 and B 5, 3. You're asked to find the points of trisection. So the points of trisection are nothing but the points which divide AB in the ratio 1:2 and 2:1. That is, if you have the line segment AB, the first point of trisection divides AB in the ratio 1:2. And the second point of trisection divides AB in the ratio 2:1. So now, what is the first point? We have already discussed the formulas for this also. So 2x1 plus x2 by 2, 2y1 plus y2 by 2, and x1 plus 2x2 by 2, y1 plus 2y2 by 3. Sorry. So let us directly use the formula. So the first point is given by 2x2 plus x1 by 3, 2y2 plus y1 by 3. And this point is given by 2x1. Sorry, this is this point. So 2x2 plus x1 by 3, 2y2 plus y1 by 3. So this point is given by 2x1 plus x2 by 3, 2y1 plus y2 by 3. So that is equal to, so let us try to do this. So 4 plus 5, 9 by 3, 2 plus 3, 2x1 plus x2, 2 plus 3, 5 by 3. So this is one point where I have multiplied these numbers by 2 and these numbers by 1. Now I need to multiply these numbers by 2 and these numbers by 1. So 10 plus 2, 12 by 3, 6 plus 1, 7 by 3. So the points are 3, 5 by 3 and 4, 7 by 3. So these are the required points of trisection. In this question, you're asked to find the ratio in which A 3 minus 4 and B minus 5, 6 is divided by x-axis and y-axis. So we can directly use the formula that we have discussed, or we can try to do it step by step. So let us do one of it by a standard process, and for the other let us use the formula. So if you want to find the ratio in which A 3 minus 4 and B minus 5, 6 is divided by x-axis. So let us say that this line segment AB meets x-axis at a point P. So we know that every point on x-axis can be assumed as x, 0, as we have discussed very early. So let the ratio be lambda is to 1. Let the ratio be lambda is to 1, which is an unknown now. So P x, 0 has to be equal to minus 5 lambda plus 3 by lambda plus 1, 6 lambda minus 4 by lambda plus 1. So I'm doing the formula mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. So this implies now you want lambda. So equate the y coefficients, because in the x coefficient this is also unknown, lambda is also unknown. You won't get a number for lambda. But here y is known and lambda is unknown. So 0 is equal to 6 lambda minus 4 by lambda plus 1. So lambda, 6 lambda is equal to 4. Lambda is equal to 2 by 3. Hence the ratio is 2 by 3 is to 1. So the required ratio is 2 by 3 is to 1, or simply 2 is to 3. So using this process, what you can also do is, once you get this lambda, if you substitute it in this x coordinate, you can find the point where this AB meets x-axis. You can also find the value of x. Just by substituting lambda is equal to 2 by 3 here, you calculate this number. That will be the x coordinate of the point where the line segment AB cuts x-axis. So now let us see whether our formula works or not. What is our formula? The ratio is nothing but minus of y1 by y2. It is minus of minus 4 by 6. That is equal to 2 by 3. So as you see, you got the exact same ratio. So now, what is the ratio in which y-axis divides AB? So let us directly do this using the formula. The formula is minus of x1 by x2. That is minus of 3 by minus 5. This minus and minus gets cancelled. So you have the ratio 3 is to 5. So this will be the answer corresponding to y-axis. In this question, you're asked to prove that the points A, B, C, whose coordinates are given, are collinear. So how do we check the collinearity using the section formula? So let us say that let A, B, C be collinear. Let us first assume that they are collinear. So if they are collinear, then B has to divide AC in some ratio. This implies B divides AC in some particular ratio. I don't know what the ratio is, but there should be some ratio. So let the ratio be lambda is to 1. So let the ratio be lambda is to 1. Now let us see whether an actual ratio exists such that B divides AC in that ratio. So 2, 4 has to be equal to minus 3 lambda plus 1 by lambda plus 1 and 9 lambda plus 5 by lambda plus 1. Now if an actual lambda exists, then you should get the same values from this equation as well as the second equation. So this implies 2 is equal to minus 3 lambda plus 1 by lambda plus 1 and 4 is equal to 9 lambda plus 5 by lambda plus 1. This implies 2 lambda plus 2 is equal to minus 3 lambda plus 1. This implies 5 lambda is equal to minus 1. Lambda is equal to minus 1 by 5. So that means B divides AC in the ratio 1:5 externally according to the x coordinate. Now according to the y coordinate, let us see what the ratio is. 4 lambda plus 4 is equal to 9 lambda plus 5. This implies 5 lambda is equal to minus 1. So lambda is again equal to minus 1 by 5. So you got the same values of lambda from the first equation as well as the second equation. So this implies that A, B, C are collinear. So hence A, B, C are collinear. In this topic, let us look at the formula to calculate area of the triangle ABC if their vertices, if the coordinates of the vertices are known. Now if A is x1, y1, B is x2, y2, C is x3, y3, then the formula for area is given as half of, you have a stair which have x1, y1, x2, y2, x3, y3 and repeated by x1, y1. So you go from x1, y1, go to x2, y2, come back to x3, y3 and close the loop by coming back to x1, y1. Now you write all the coordinates and the downward arrows are to be added and the upward arrows are to be subtracted. So the area is equal to half of modulus of the downward arrows. The numbers connected by downward arrows have to be multiplied and added. It is x1, y2 plus x2, y3 plus x3, y1. So these three has to be added minus x2, y1 minus of x2, y1 plus x3, y2 plus x1, y3. So whatever number you get, the summation of these minus the summation of this, whatever number you get, the modulus of that will be the area. So the number that you get here may be positive or negative depending on the order in which you take the coordinates. But you have to finally take the mod of the number which you get here. That will be the area of the triangle. So the derivation for this is quite simple. So if you have the points x1, y1, x2, y2 and x3, y3, drop the perpendiculars. So the area of this triangle is nothing but area of trapezium ABQP plus area of trapezium BCRQ. So area of this trapezium plus area of this trapezium minus of area of this trapezium minus of area of PRCA. So if you add this trapezium plus this trapezium minus this trapezium, you have the area of triangle ABC. So you know how to find the area of the trapezium. So half H is PQ, which is x2 minus x1, x2 minus x1, half H times A plus B, that is the sum of the parallel sides. This is y1, this is y2. So you have y1 plus y2 plus half times x3 minus x2 times y2 plus y3 plus half times the area of the trapezium which is at the bottom is half times the difference between the distance between P and R is x3 minus x1 times y1 plus y3 mod of this. So that will be the actual formula for area. So if you simplify this, some terms will get cancelled, and if you group the terms, you get exactly this formula. So what you usually do is you don't try to do this. Derivation is not required for you. You just need to remember the final formula. Half of this stair. You write the first coordinates, second coordinates, third coordinates followed by the first coordinate. You have to complete the rotation. You have to completely surround the triangle. You come back to the original point and then draw the downward arrows. Downward arrows have to be multiplied and added. Upward arrows have to be multiplied and subtracted. So this gives you the area of the triangle. So let us take a small example to see how this has to be applied. So if you are asked to find the area of this triangle, the first vertex is 1, 2, second vertex is 4, 6, the third vertex is 3, 5. So let us try to see how to apply the formula. So area is equal to half of the stair of x1, y1, 1, 2, 4 minus 6, the second set of coordinates, the third set of coordinates followed by the first set of coordinates. So now the downward arrows have to be multiplied and added. That is equal to half times in the bracket 1 into minus 6 is minus 6, 4 into 5 is 20, 3 into 2 is 6, minus of the summation of the upward arrows. 4 2s are 8, 3 into minus 6 are minus 18, 1 into 5 is 5. So you have to take the mod of this. That is equal to half times mod of plus 6 minus 6 gets cancelled. So 20 minus of 5 plus 8 is 13, minus 18 is minus 5. Minus 18 plus 13 is minus 5, minus of minus 5. That is equal to 25 by 2. That is equal to 12.5 square units. So 25 by 2 is 12.5 square units. So the area of this triangle is 12.5 square units. So what you need to understand is, sometimes if you take another order, you might end up with another number. For example, if you take area as half times, so if you change the order, so instead of this order, first you write this 4 minus 6, next you write 1 2, next you write 3 5, and complete this with 4 minus 6. So let us see what the number that comes now. So 4 2s are, so the downward arrows are positive. So 8 plus 5 minus 18, minus of upward arrows are minus 6 plus 6, minus 6 plus 6 plus 20. That is equal to half times 13 minus 18 is minus 5 minus of 20. So this time, as you can see, you get minus 25. But once you take mod, it becomes plus 25 by 2, again is 12.5 square units. So whatever order you take, you get the exact same number. For some orders, you might get a positive number. For some orders, you might get a negative number. But once you take mod, you always get the right value for area. The collinearity of 3 points A, B, C. So collinearity of 3 points A, B, C can also be checked using the area of triangle formula. Can also be checked using the area of triangle formula. If area of triangle ABC is equal to 0, if area of triangle ABC is equal to 0, this implies A, B, C are collinear. Obviously, if triangle ABC has area 0, that means all these 3 points have to lie on a straight line. So if you take a very simple example, A is 1, 5, B is 5, 1, and C is -3, K. So find the value of K for which these 3 points are collinear. So find the value of K for which these 3 points are collinear. So how do we do this? The simplest way is to find the area of triangle ABC and equating it to 0. So what is the area of triangle ABC? Half times 1, 5, 5, 1 minus 3K completed by 1, 5. So this has to be equal to 0. This implies, so this half goes onto that side, it gets cancelled. So the downward arrows have to be added, right? So 1 plus 5K minus 15 minus of, the upward arrows are 25 minus 3 plus K is equal to 0. So this implies 5K minus 14 minus of 25 minus 3 is 22 plus K is equal to 0. So 5K minus K is 4K minus 14 minus 22 is minus 36 is equal to 0. 4K is equal to 36, hence K is equal to 9. That means if K is equal to 9, then the area of the triangle ABC is equal to 0. That means the points A, B, C are collinear. So now that you have understood how to find the area of a triangle, so now let us see how to find area of a polygon. It is any sided figure. So let us say that you have A1, A2, A3, A4, so on up to An. You have an n-sided polygon with n vertices. So let the first vertex be x1, y1, the second vertex be x2, y2, third vertex be x3, y3, fourth vertex be x4, y4, so on, the nth vertex be xn, yn. So let us say that these are the n vertices of a polygon. Now you are asked to find the area of the polygon formed by these vertices. So the formula for area of the polygon is given by the stair method, which is half of, so construct a stair consisting of the first coordinate x1, y1, x2, y2, x3, y3, x4, y4, so on. So you write, so you go on till xn, yn. So x1, y1, x2, y2, x3, y3, x4, y4, so on up to xn, yn, and complete the cycle by x1, y1. Write all these numbers. Again, do the same process as we have done for triangle. That is, the downward arrows are to be multiplied and added. The upward arrows are to be multiplied and subtracted. So that is equal to half times mod of x1, y2 plus x2, y3 plus x3, y4 plus so on up to xn, y1 minus of x2, y1 plus x3, y2 plus x4, y3, so on. So the product of the numbers correspond to the downward arrows minus the products correspond to the numbers in the upward arrows. So half of this will be the area of the polygon. But there is an important point that needs to be remembered. There is a very important problem which you get when you're dealing with polygons. So in the polygons, all the vertices x1, y1, x2, y2, x3, y3, so on have to be taken in a specific order. So the vertices have to be taken in a specific direction. That is either clockwise or counterclockwise. For example, if I take the vertices in this direction, that means I am going in counterclockwise direction. I can also take the vertices in this direction and come back to my original point. That is called clockwise direction. You have to either take all the vertices in counterclockwise direction or in clockwise direction. So if you take the vertices in clockwise direction, you get the sign of this expression as negative. You have to take mod, anyway you get the positive answer. If the vertices are taken in counterclockwise direction, you directly get a positive answer. So after taking mod also, that number remains positive. So what you cannot do is assume that you have these 4 vertices A, B, C, D. You cannot take x1, y1 first and then this vertex and then this vertex and then this vertex and come back. So if you haphazardly take the order of the vertices, the answer will not turn out to be same. So you can either go in this direction, A to B, B to C, C to D, back to A, or in the reverse direction. So if you go in the counterclockwise direction, you directly get a positive number. If you go in the clockwise direction, you get a negative number, but once you take mod, that will become positive. In this question, you're asked to find the area of pentagon formed by these 5 points. So whenever you have a polygon which has more sides than a triangle, so in triangle you don't need to worry about the order in which you take the coordinates. You take the vertices. But in a pentagon or a quadrilateral, for instance, if the number of sides is more than 3. So first you need to ascertain the relative positioning of these points before applying the staircase method. So first what we do is, let us take 1, 1. So 1, 1 may lie somewhere here. So let us take this as 1, 1. So 7 minus 3, 7 comma minus 3 might lie somewhere here. 7 comma minus 3. And 7 comma 21, 7, 21 may lie somewhere here. Next 0 minus 3, 0 minus 3 might lie somewhere here. This is the 4th point. So this is 7, 21. This is 0 minus 3. And finally 12, 2. So you have 12, 2 somewhere here. So you don't need to plot the points exactly. Just need a rough idea of how the placement of points are. So according to the given question, the first vertex is this, the second vertex is this, the third vertex is this, the fourth vertex is this, the fifth vertex is this. So as you can very clearly see, the pentagon's vertices are not in the order that is given in the question. So if you join the vertices exactly in the same order as given in the question, you won't get a pentagon. So A to B, B to C, C to D, D to E won't get a pentagon. So what is the correct order of vertices that you have? So A can go to D, then to B, then to E, then to C, then back to A. So the order is A, D, B, E, C, back to A. So now you need to apply the staircase method for this order of vertices. So you can go either in clockwise direction or in counterclockwise direction. As we have seen, if you go in counterclockwise direction, you directly get the positive value. So let us go in this direction, back here. So area is equal to half of 1, 1, 0 minus 3, 7 minus 3, 12, 2, 7, 21 and back to 1, 1. That is equal to half of mod of, so the downward arrows are minus 3, 0 plus 0 plus 14 plus 12 times 21. 12 into 20 is 240 plus 12 is 252 plus 7. So these are the downward arrows which needs to be added, minus the upward arrows 0, minus 21, minus 36, plus 14, plus 21, the mod of this. That is equal to half of 252 plus 7, 259 plus 11, 259, 260 is 270 minus of, so plus 21 minus 21 gets cancelled, minus 36 plus 14 is minus 22, minus of minus is plus, so plus 22, that is equal to 292 by 2, 146 square units. So as we have discussed, if you take the points in the counterclockwise direction, the number that you get will automatically be positive. For example, if you take the numbers in clockwise order, so just do the same process, you'll see that you get the exact same number with a negative sign. So you get minus 292 by 2. So once you take mod, you get the same answer. But remember that if you haphazardly take the vertices as you want, you won't get the correct solution. That means if you take the vertices exactly in the order that is given in the question, that is A to B, B to C, C to D, D to E, and back to A. So if you calculate the numbers, that won't give you the correct answer. So keep in mind, in a polygon, so you just have to plot the points roughly, see the relative placement of the points, and go from vertex to vertex in a specific order. So in this video, let us look at the formulas for centroid, incenter, and excenters. So first, if you have a triangle ABC, so let the vertices of the triangle be x1, y1, x2, y2, and x3, y3. So now let us say that you're asked to find the centroid of this triangle. So we know that centroid is the point of concurrency of medians. Centroid is the point of concurrency of medians. So first we draw the medians. So if you draw the median AD, so median is nothing but the line joining the vertex with the midpoint of the opposite side. So D can be written as x2 plus x3 by 2, y2 plus y3 by 2. Now we know that the centroid divides the median in the ratio 2:1. Now you know the coordinates of point D, you know the point A, you know the ratio in which the centroid divides AD. So if you apply the section formula, you get centroid is equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. That is the average of x coordinates, the average of y coordinates. So that will be the coordinates of centroid. And centroid is also the center of gravity of a triangle. So if you have a triangular plate, what is the point on which you can balance the triangle? So the point of balance is nothing but the center of gravity, which can be obtained from the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Next, if you go to the incenter of a triangle, incenter is nothing but the point of concurrency of the angle bisectors. So if you draw the angle bisectors of all the three angles, they intersect at a point which is called the incenter. Now how do we find the incenter of the triangle using the section formula? So in properties of triangles, we have derived certain ratios which angle bisector tends to do. So the first ratio comes from angle bisector theorem. So angle bisector theorem states that an angle bisector divides the opposite side in the ratio of adjacent sides. It is BD by DC is equal to this ratio. This length is to this length is equal to this side is to this side. It is C by B. The side opposite to vertex C is called small c. The side opposite to vertex capital B is called small b. So BD is to DC is equal to C is to B. So from this ratio we can get the coordinates of D, because we know the ratio in which D divides BC. Next, you have another formula which states that the in-center divides the angle bisector AD in the ratio. In-center divides AD in the ratio AI by ID is equal to this length by this length is equal to the sum of adjacent sides is to opposite side. That is B plus C is to A. So if you write the same equations with respect to the angle bisector of B, so if you draw the angle bisector of B, if this is E, so AE by EC will be equal to C is to A, and BI is to I is equal to A plus C is to B. So this is how the ratio works. So using these two ratios, so you can very clearly see that you can find the coordinates of I. So using the angle bisector theorem, you can find the vertex D, and using this ratio, you can find the vertices of I. So once you apply, you get the vertices of I as AX1 plus BX2 plus CX3 by A plus B plus C, comma AY1 plus BY2 plus CY3 by A plus B plus C. So A times X1, here also you have cross multiplication. This side into the opposite vertex. Next side into the opposite vertex. Next side into the opposite vertex. So AX1 plus BX2 plus CX3 by A plus B plus C. AY1 plus BY2 plus CY3 by A plus B plus C. So these are the formulas for in-center. Now let us go for X-center. What is X-center? X-center is the point of intersection of one interior angle bisector and two exterior angle bisectors. So draw two exterior angle bisectors, one interior angle bisector. The point of concurrency is called the X-center. So there are three X-centers. X-center opposite to vertex A, X-center opposite to vertex B, X-center opposite to vertex C. So how do we find the coordinates of X-center? Again, you have the angle bisector theorem from which you get the point D, and the X-center theorem says that AEA by EAD is nothing but again B plus C by A, but an external ratio. So the ratio in which the X-center opposite to vertex A divides AD is again B plus C is to A, but externally. So using this ratio, you can find the coordinates of X-center. So X-center opposite to A is given by minus AX1 plus BX2 plus CX3 by minus A plus B plus C, minus AY1 plus BY2 plus CY3 by minus A plus B plus C. So if you want the X-center opposite to vertex A, so you have to put minus A in both numerator and denominator. So the minus comes with the terms corresponding to A. If you want EB, so you got AX1 minus BX2 plus CX3 by plus A minus B plus C. So whichever X-center you want correspond to those vertices and sides, you put a minus sign. So this gives you the formula for x-center. So I hope you have understood how to find in-center and x-centers. In this example, you're given the 3 vertices of a triangle and you're asked to find the centroid of the triangle. So the centroid of the triangle is given by, you already have the formula, the average of the x coordinates and the average of the y coordinates, that is 0 plus 2 plus 7 by 3, 0 plus 5 plus 4 by 3, that is equal to 7 plus 2 is 9 by 3 is 3, 5 plus 4 is 9 by 3 is again equal to 3. So the centroid is 3, 3. In this question, you're given 3 vertices of a triangle. You're asked to find the in-center. So to find the in-center, first you need to find the values of the sides of the triangle. So let us take that this vertex is A, this vertex is B, this vertex is C. So what is the length small a? Small a is nothing but the distance between B and C. That is 20 minus 0, 20 square plus 7 minus of minus 8 is 7 plus 8. That is 15 square. That is equal to, if you take a 5 common, you get root of, this is 5 square times 4 square. 4 square plus 3 square, that is 25. So 5 into 5 is 25. So if I want the length of the side B is nothing but length of AC. So minus 36 minus 0, that is minus 36 whole square plus 7 plus 8 whole square, 15 square. That is equal to, so if you take a 3 common, so 3 times root of, so this is 3 into 12, so 12 square plus 5 square, this is nothing but 13. 13 times 3 is 39. Next, the vertex, the side C is nothing but the distance between A and B. 36, 20 plus 36, 56 square plus 7 minus 7 is 0, 0 square is equal to 56. So you got all the 3 sides A, B, C. Now the formula for in-center is A times x1 is 25 times minus 36 plus B times x2 39 times 20 plus C times x3 0 by A plus B plus C, 25 plus 39 plus 56. And what is the y coordinate? Again A y1 25 times 7 plus B y2 39 times 7 again plus 56 times minus 8 by 25 plus 39 plus 56. So you can try to calculate these values. 56 into 0 is 0. So you have 1 0 here. Next, 25 into 36, 39 into 20. You can just calculate these values. It turn out to be minus 1 and this will turn out to be 0. So the in-center of the triangle ABC is minus 1, 0. So I hope you learned how to apply the formula. A times x1 plus B times x2 plus C times x3 by A plus B plus C. Next, A times y1 plus B times y2 plus C times y3 by A plus B plus C. So minus 1, 0 is the in-center of the triangle. In this video, let us look at the topic of locus. So first, what is a locus? The path followed by a point satisfying a given condition is called the locus of a point. The path followed by a point satisfying a given condition is called locus of the point. So let us try to physically understand what locus is. For example, if you are asked to find the locus of a point which maintains a constant distance from a given point, I want the locus of a point whose distance from a given point is constant. So how do we understand this? So that means you have a given point. Let us call this given point A. Now I want the locus of point whose distance from this point is always constant. So let the constant be k. Now what is the path of the point which moves such that the distance from A is always equal to k? So let us take a point P which is at a distance of k units from A. So if you don't want to change this distance from A, what is the path in which you can move this point? Obviously, it's very clear that the path of point P has to be a circular path, right? Has to be a circular path. So the locus of a point whose distance from a given point is k is a circle with center as the given point, and radius equal to k. So the locus of a point whose distance from a given point is constant is a circle with center as the given point and radius equal to k. So let us take another example. Next, you are asked to find the locus of a point equidistant from two given points. Assume that you are given 2 points A and B. So what is the path of the point? What is the path followed by the point such that it is equidistant from these 2 points? Obviously, if you join A and B, the midpoint of AB is equidistant from these 2 points. Now let us start from here. Now, what is the direction in which this P can move? So if P moves in this direction, obviously it is going closer to B than to A. So the distance from B will be lesser than the distance from A. So P won't be equidistant from A and B. So it cannot move towards A also. It has to be equidistant from A and B. So it can neither move towards A nor move towards B. So what is the direction in which it can move? So it can move in the direction perpendicular to AB, in this direction as well as in this direction. That means the locus of a point equidistant from 2 given points is their perpendicular bisector, right? Is their perpendicular bisector. If you take the perpendicular bisector, if you take any point P on this perpendicular bisector, PA will always be equal to PB, because this angle is 90 degrees. This side is common to these 2 triangles, and this side is equal to this side because P is the midpoint. Hence these 2 triangles are congruent, hence PA is equal to PB. So if you take any point on this perpendicular bisector, it will be equidistant from A and B. Hence the locus is the perpendicular bisector. Next, you are asked to find the locus of a point whose distance from a given line is constant. This time you have a given line. Let this be the given line. Now you are asked to find the locus of a point whose distance from this line is always constant. So let us say that the constant be equal to k. So I want a point which is at a distance of k units from this line. Now I want the locus of this point. The condition that this point has to satisfy is it has to maintain this distance. So obviously it cannot go like this or like this, because if it goes like this, the distance will be increasing. If it goes towards the line, the distance will be decreasing. So what is the direction in which it can go? It has to go parallel to the given line, such that this distance will always be equal to k. So you can have a parallel line above this line or a parallel line below this line, such that this distance is equal to k. So the locus of a point whose distance from a given line is a constant is a pair of parallel lines at a distance of k units from the given line. At a distance of k units from the given line. So I hope you understand certain examples on locus. This is the physical way in which you understand the concept of locus. The next topic that we are going to learn is the equation of locus. So what is the equation of locus? So the equation of locus is an algebraic condition which each and every point on locus satisfies. So once you go to the equation of locus, you have to derive a mathematical condition which each and every point on the locus satisfies. So obviously, if you're asked to find the locus of the equation of locus of a point, your question has to be more specific. For example, what is the equation of locus of a point whose distance from 3, 2 is equal to 5? So now the question has to become more specific. What is the equation of locus whose distance from this particular point, let us call it P, is equal to 5? That means if you take the coordinate system, you have the point 3, 2. So let us call this point 3, 2. Now I want the locus of a point such that the distance from this point is equal to 5 units. So the process is very simple. So first step, let AH, K be a point on the locus. So this is the first step in 99% of the locus questions. So we assume that a general point H, K is a point on the locus. So let us say that a point A, H, K lies on the locus. Now, what is the condition that this A has to satisfy? According to the given question, the distance from A to P has to be equal to 5 units. So according to the question, AP has to be equal to 5. So this has become partially mathematical equation. So now let us completely convert this into a mathematical condition. Now what is the formula for AP? What is the algebraic expression for AP? AP is nothing but root of h minus 3 whole square plus k minus 2 whole square from distance formula. So this is equal to 5. So now we have gone to a certain level of algebraicness. So this implies if you square it on both sides, you get h minus 3 whole square plus k minus 2 whole square is equal to 25. So once you got an equation completely in terms of h and k without any other variables, you got the locus. So once you got an equation in h and k, you just need to replace h with x and k with y to get the equation of locus. So equation of locus is x minus 3 whole square plus y minus 2 whole square is equal to 25. So this will be the answer to the question. So now let us look at some more complicated loci. In this question, you're asked to find the locus of a point equidistant from these 2 points 1, 0 and minus 1, 0. So you have a point minus 1, 0 and the point 1, 0. I want my point P to be equidistant from these 2 points. So let us start the working. First step is let PH, K be a point on the locus. So that's the first step that is needed to convert the given question into an algebraic model. So PH, K be a point on the locus. Next, what is the condition that P has to satisfy? P has to be equidistant from A and B. So PA has to be equal to PB. So this implies, now once you write the condition in semi-mathematical language, you convert this into an algebraic equation. So PA is nothing but root of h minus 1 whole square plus k minus 0 whole square is equal to root of h minus of minus 1 is plus 1 whole square plus k minus 0 whole square. So this implies, let us square it on both sides. So you get h minus 1 whole square plus k square is equal to h plus 1 whole square plus k square. So this k square and this k square gets cancelled. So this implies h square minus 2h plus 1 is equal to h square plus 2h plus 1. So h square and h square gets cancelled, 1 and 1 gets cancelled. This implies 4h is equal to 0 and this implies h is equal to 0. So finally you got an equation completely in terms of h and k without any extra variables. So this implies once you get the equation, you just need to put x in the place of h and y in the place of k. So you don't have k here. So the equation of locus is x is equal to 0. So this will be the equation of locus this time. So you can see that the question has become more specific. You are not just asked to find the nature of locus. You are asked to find the exact equation of locus. So this is how we do the question. In the next example, you are given that a rod of length L slides on coordinate axis. Find the locus of midpoint of the rod. So you have a rod of certain length L. Now this rod is sliding on this coordinate axis. As this rod is sliding on the coordinate axis, what is the locus of the midpoint of this rod? So you can think of this question as something like this. You can think of the question as you have a ladder of length L. Assume that the ladder initially is vertical. Now you have alighted the ladder till its midpoint. Now someone comes and slides the ladder. Someone comes and slides the ladder. So what is the path in which you fall down? You are exactly at the midpoint of the ladder. Obviously you won't fall down directly vertically downwards, right? Because you are not jumping from the ladder. You are just standing at the midpoint of the ladder. So as the ladder slides, you take certain path. That is, if the rod is vertical, the midpoint is somewhere here. As the rod is sliding, the midpoint has come here at some point, and as the rod has completely come to rest, the midpoint has gone somewhere here. So the path will be approximately in this, along this curve. So you're asked to find the equation of this curve. So now this is a slightly more involved question, but we start with the same premise. The first step is let PH, K be a point on the locus. So let PH, K be a point on the locus. That means as this rod is sliding at some instant, let us say that the midpoint of the rod is H, K. Now, how do we convert the condition which is given? So the condition is that PH, K is the midpoint of this rod. So how can you create a mathematical condition corresponding to this physical condition? Now we know that P is the midpoint of this ladder. So how can you construct a mathematical equation corresponding to this? So you can think of different ways of writing the mathematical equation. So without any extra numbers, it is very difficult to write the equation corresponding to H, K. So this condition is not a direct condition. Okay, P, H, K is the midpoint, but what equations can I write? So H is equal to something, K is equal to something, I don't know what to write. So in such cases, we create new variables. So we create new variables. These are nothing but algebraic variables. So let us say that, let us call this point as A, this point as B. And as the ladder moves, these 2 points A and B also move. These points A and B also move. Just imagine the animation. Imagine an animation where this rod is sliding along the coordinate axis. So as the rod is sliding along the coordinate axis, this point and this point obviously changes, right? So let us say that the coordinates of A are A, 0. I don't know what A is, but I know that the y coordinate is 0. And let us assume that the coordinates of B are 0, B. A and B are the new variables. So assume A as A, 0 and B as 0, B. Now, using these variables, write the equations if you can. Now what is the condition? PH, K is the midpoint of this. So PH, K is equal to, so the midpoint is A plus 0 by 2 and 0 plus B by 2. Now you are able to write some equations. So H is equal to A by 2 and K is equal to B by 2. So you got two equations. Now what is the equation of the locus? Equation of locus is some algebraic condition only in terms of H and K. So you should not have any A and B's. That means you need to eliminate A and B. So your aim is to eliminate A and B. So remember, in deriving the equation of locus, whatever the number of new variables you have introduced, you need to have one extra equation. In this question, you have introduced two new variables, so you need three equations to eliminate two variables. So to eliminate two variables, we need three equations. So you have already two equations with you. So what is the third equation which is present in this question? The third equation which I have not used till now is that the length of the rod is fixed. As the rod is sliding, the length of the rod is not changing. So what is the length of the rod? The length of the rod is root of a square plus b square, right? Root of a minus 0 whole square plus 0 minus b whole square is equal to L. This implies a square plus b square is equal to L square. And what is a? 2h. So a is 2h, b is 2k. So 4h square plus 4k square is equal to L square. Now you got an equation completely in terms of h and k. So remember the difference between variables and constants. Here L is a constant, so you can have L in the equation. But a and b are variables. As this rod is sliding, a and b are changing. So you have to eliminate the variables. Constants need not be eliminated. So the equation of locus is nothing but x square plus y square is equal to L square by 4. So this will be the answer to this question. In this question, you're given that two vertices of a triangle are 1, 2 and 4, 3. So you have a triangle whose two vertices are fixed at 1, 2 and 4, 3. And the third vertex moves on the line y is equal to 3x. It means the third vertex is a variable point. So let us draw the line y is equal to 3x. So C is, the third vertex is a point on this line. Now find the locus of the centroid of the triangle. That is the question. So now as you can see, this question you can think of an animation. So where two vertices of a triangle are fixed, the third vertex is moving along this line. So as this vertex moves along this line, the shape of the triangle is changing. As the shape of the triangle is changing, the centroid of the triangle also changes, obviously. So what is the path in which the centroid of the triangle changes? That's the question. So let us start with our original assumption. So let PHK be a point on the locus. So if PHK be a point on the locus, it has to be the centroid for some position of C. It has to be the centroid of this triangle for some position of C. Now, as you can see, the position of C is changing. Now, if you want to construct the condition on h comma k, so we know the condition satisfied by h comma k. H comma k is the centroid of this triangle. So now how do I write the equation correspond to this centroid? So h comma k by formula it is 1 plus 4 plus x coordinate of C by 3 and 2 plus 3 plus y coordinate of C by 3. So if I have to complete this equation, I need some way to represent this point C. So let us try to represent this C with some variables. So let us say that the point C is of the form a comma b. So these are the variables that I am assuming. So as C moves, the coordinates a and b changes. So if I assume C as a comma b, so the equations will be h comma k is equal to 1 plus 4 plus a by 3, 2 plus 3 plus b by 3. This implies h is equal to 5 plus a by 3, k is equal to 5 plus b by 3. So you have two equations. So what is the accounting that we have discussed? Whatever the number of variables that you have introduced newly, the number of equations have to be one more than the number. So you have introduced two variables, so you need to get three equations. So you got one equation, you got two equations. you need to try and get the third equation. So what is the third equation? The third equation is that this point CA comma B lies on the line y is equal to 3x. That means this point satisfies this equation. So B has to be equal to 3 times A. B has to be equal to 3 times A. So this is the third equation. So once you got all 3 equations, now your aim is to eliminate A and B. So let us try to do that. So 3h is equal to 5 plus A. This implies A is equal to 3h minus 5. And 3k is equal to 5 plus B. This implies B is equal to 3k minus 5. So you have A, you have B. So what is the third equation? B is equal to 3A. So to eliminate A and B, so 3k minus 5 is equal to 3 times 3h minus 5. This implies 3k minus 5 is equal to 9h minus 15. Once you got the equation in terms of h and k, just need to replace h with x and k with y. This implies 9x minus 3y is equal to 10. 9x minus 3y is equal to 10. So this will be the required equation of locus. So I hope you understand the steps that are involved in finding the locus. So as we go on and on in our knowledge of coordinate geometry, you get more and more complicated questions on locus. So welcome students. In this video, let us look at the steps that are involved in finding the locus of a point. So you have a very standard algorithm by which you can do most of the locus questions. So the first step whenever you do a locus question is to let PH comma K be a point on the locus. So this is the usual point where we start our locus questions. Let PH comma K be a point on the locus. In the second step, we observe the conditions. We observe the conditions that are being satisfied by PH comma K. So we observe the conditions that are being satisfied by H comma K, and we try to express them mathematically. So try to express them mathematically. So whenever you try to express the conditions mathematically, you may need some new variables. So when you try to express them mathematically, you may be needed to introduce some new variables. So introduce some new variables if required. So try to express them mathematically by introducing some new variables if required. And so let us say that n new variables are introduced. So let us say that n new variables are introduced. So the next step is create n plus 1 equations. Whenever you introduce n new variables, you need to create one equation more than the number of variables that you have introduced. So create n plus 1 equations. The info required will be given in the question. So you need to read the question carefully to get all the information, all the conditions that you need to create n+1 equations. So once you create n+1 equations, eliminate the new variables, that are created, So once you eliminate the variables, get an equation completely in terms of h, k. So once you eliminate the new variables that you have created, you get an equation completely in terms of h and k. So once you get the equation completely in terms of h and k, replace h by x and k by y, replace h by x and k by y. So the equation in x, y is the required equation of locus. So whatever is the equation which is left is the equation of locus. So these are the 6 steps that you need to follow to complete your question on locus. So I hope you have observed these steps in the examples that we have done already. In this topic, let us look at the transformation of axis. We have already seen the basics of Cartesian coordinate system. That is, if you have a coordinate system containing x-axis and y-axis, every point in this plane can be represented by a unique ordered pair. Now, the thing that we are going to learn in this topic is how the coordinates of a point change as we change the coordinate system. For example, if you have an original coordinate system consisting of x-axis and y-axis. Now, without changing the direction of x-axis and y-axis, let me shift the coordinate system to a point h, k. Now let this be the new coordinate system. So if you take a point P, with respect to old coordinate system, this point P has some coordinates. With respect to the new coordinate system, the same point P will have some other coordinates, right? Now what we are going to study is how are the old coordinates related to new coordinates. So I hope this is clear. Next, let us look at the rotation of axis. This is called shifting of origin. We don't change the direction of x-axis and y-axis, we just shift the origin to some other point. This results in change in the coordinates of the point. Similarly, the next transformation that we are going to look at is a rotation of axis. This time we don't change the origin of the coordinate system, we just rotate the axis through some angle theta. With this operation also, you can see that the coordinates of the point change, because by definition, what are the coordinates of the point? The coordinates of the point are the distances from the coordinate axis measured in the direction of coordinate axis, right? So if you take the old coordinates as small x, small y, the old coordinates are nothing but this distance and this distance. This distance is small x, this distance is small y. Now as the axes are rotated through an angle theta, now what is the new x coordinate and new y coordinate? Now the distances have to be measured in this direction and this direction. So if you measure the distances, so this will be the new x coordinate, this will be the new y coordinate. As you can very clearly see, the numbers are changing. Here also, the old coordinates are this distance and this distance, and the new coordinates are this distance and this distance. Obviously, the new coordinates depend on old coordinates. Here also the new coordinates depend on old coordinates. But what we are going to see in this topic is the exact relation between the old coordinates and the new coordinates. So there are two types of transformations that we are going to look at. One is shifting of origin. That is, without changing the direction of x-axis and y-axis, we just take the origin to some other point. It is called shifting of origin. The second type of transformation that we are going to look at is rotation of axis. So what happens when you shift the origin? What happens when you rotate the axis? Now let us try to understand these two operations one by one. The first operation that we're going to look at is shifting of origin. So let us say that you have an original coordinate system which is denoted by small x, small y. This is a standard convention. So old system is denoted by small x and small y. Even the old coordinates of the point are denoted by small x comma small y. And the coordinates according to the new system is denoted by capital X comma capital Y. So let us use this convention. So now let the old axis be small x small y and the new axis be capital X capital Y. So let us say that the origin has been shifted to some point h comma k. Now you have a point on this xy plane. The old coordinates of this point is small x small y and the new coordinates are capital X capital Y. The question is, how are old coordinates related to new coordinates? It's very straightforward. Let us see. You can see that the numbers small x small y are nothing but this distance and this distance, right? Small x is the distance of this point from old y-axis. So this total distance is small x and this total distance is small y. Now, what is capital X and capital Y? Capital X is the distance of this point from the new y-axis. So this distance is nothing but capital X and this distance is nothing but capital Y. Now what is the relation between small x and capital X, small y and capital Y? So that relation will depend on where the origin is shifted. So as you can see, this point is nothing but h comma k. That means this distance is nothing but h and this distance is nothing but k. H is the distance of this point from y-axis. K is the distance of this point from x-axis. Now as you can very clearly see, if this is h, this is also equal to h. If this is k, this length is also equal to k. So what are the relations? As you can see, small h plus capital X is equal to small x. K plus capital Y is equal to small y. So this implies capital X is equal to small x minus h. Capital Y is equal to small y minus k. This is the simple relation between capital X capital Y and small x small y. So let us take a very simple example. If origin has been shifted to the point 2, 3. So let us say that the new origin is 2, 3. So find the new coordinates of the point whose original coordinates are 5, 7. So assume that you have a point P whose coordinates are 5, 7. So now you are asked to find the new coordinates of this point P once the origin is shifted to the point 2, 3. Again, you just need to use the formula. So capital X is equal to small x minus h, that is equal to 5 minus 2, which is equal to 3, and capital Y is equal to small y minus k. This 7 minus 3 is equal to 4. That means the new coordinates of the point 57 is nothing but 3, 4. As simple as this. So if you have an old coordinate system, represent the old coordinates by small x, small y, represent the new coordinates by capital X, capital Y. And if the origin is shifted to the point hk, then capital X is equal to small x minus h, capital Y is equal to small y minus k, and small x is equal to capital X plus h, small y is equal to capital Y plus k. So if capital X, capital Y are given, if small x, small y are asked, you can use these equations. So shifting of origin is quite simple. In this video, let us look at the transformation, which is rotation of axis. For example, let us have the original coordinate system small x, small y, and O is the origin. Now, without changing the origin, let us rotate the axis through an angle of theta. So this theta is a given angle. Now, if you have point P whose original coordinates are x, y, small x, small y, let the new coordinates with respect to the new coordinate system be equal to capital X, capital Y. Now the question is, how is capital X, capital Y related to small x, small y? Let me write the answer first and let me try to derive this. So those are interested only in the answer part, you can just remember the answer that we are writing and skip the derivation. So the transformation is something like this. Capital X, capital Y is equal to small x cos theta plus small y sin theta. Capital Y is equal to minus x sin theta plus y cos theta. So this is the formulas for the new coordinates in terms of old coordinates. Now, the old coordinates in terms of new coordinates is nothing but capital X cos theta minus capital Y sin theta, capital X sin theta plus capital Y cos theta. These are the formulas to get back the original coordinates from the new coordinates. So let us also see how to remember these formulae. But for that, let us go to the derivation. First, to do the derivation, first let us join the origin with the point and let the distance of the point P from O be denoted by R. And we know that R is equal to root of x square plus y square, which I'll be substituting if required at later stages. So let this length be R. And let us consider that this ray OP makes an angle of phi with the original axis. This ray OP is making an angle of phi with the original axis. So if it makes an angle of phi with the original axis, it obviously makes an angle of phi minus theta with the new axis. So now let us write the equations. So using the concepts of polar coordinates that you have studied, can I write small x as r cos phi, right? Because this ray is making an angle of phi with the original axis. So small x is equal to r cos phi, small y is equal to r sin phi. These are the expressions for the original coordinates in terms of r and phi. Next, if you take the new coordinate system, in the new coordinate system also, because the origin is not changed, the distance of the point P from origin is again equal to r. But the difference is the angle that this ray makes with the x-axis. So this time, can I write capital X is equal to the new coordinate of the point P, the capital X is equal to r times cos of phi minus theta. Cos of phi minus theta. And capital Y is equal to r times sine of phi minus theta. Now once you have these four equations, you have the derivation with you by using the compound angle formulas in trigonometry. That is equal to r times cos phi cos theta plus sine phi sine theta. This is equal to r times sine phi cos theta minus cos phi sine theta. That is equal to, so now r cos phi is x, so r times cos phi is x, so small x cos theta plus r sine phi is nothing but small y, so small y sine theta. Capital Y is equal to, you can see r sine phi as y, r sine phi is y, and r cos phi is nothing but small x. So this becomes minus x sine theta plus r sine phi is small y, so small y cos theta. So we effectively got the derivation for capital X and capital Y. So capital X is equal to cos theta times x plus sine theta times y, and capital Y is equal to minus x sine theta plus y cos theta. So if you solve this by considering this as a linear equation, we can get small x and small y also in terms of capital X and capital Y. So I want you to do the derivation for small x and small y. So once you do the derivation, you get small x small y is equal to capital X cos theta minus capital Y sin theta, and small y is equal to capital X sin theta plus capital Y cos theta. So these are the formulas for capital X, capital Y and small x, small y. Now, before going forward, let us try to see how to remember these results carefully. So we can very easily remember these formulas using matrix interpretation of these equations. So as you can see, the first equation is xy is equal to cos theta sin theta minus sin theta cos theta times small x small y, right? So this is the matrix interpretation, matrix form of these equations, and small x small y is equal to cos theta minus sin theta cos theta times capital X capital Y. So as you can see in these equations, only this is something which you need to remember separately. Now if you want to remember this, you just need to keep this diagram in your mind. So if you keep this diagram in your mind, you can very clearly see that the distance of capital X is more than the distance of small x. This is just a way to remember. This is not always true, but in our diagram, the value of capital X looks bigger than the value of small x. The value of capital X looks bigger than the value of small x. So capital X will be small x cos theta plus small y sin theta, because you need a bigger number you need to add. Just remember that. If you want a bigger number, you need to add things. So capital X has something plus something. So if you remember that much, you can go and remember all the remaining things. So the technique is to observe that this and this matrices are matrices with determinant is equal to 1. determinant is equal to 1. So cos square theta plus sin square theta, cos square theta plus sin square theta. And you can very clearly see that cos theta is always positive. Cos theta is always positive. The difference is just that you have plus sin theta here, minus sin theta here, minus sin theta here, plus sin theta here. So if you just remember, capital X has plus sin theta, automatically capital Y should have minus sin theta, and automatically if you have plus sin theta here, you have to have minus sin theta here. If you have minus here, you have to have plus here. So if you just remember this part, that capital X should have both cos and sin as positive, and the matrix should always be such that the determinant is equal to 1. So if you remember that, you won't write sin theta here because you want cos square theta plus sin square theta. So the plus minus always occurs with sin theta, and capital X has both terms as plus. So if you remember this much, you can write the equations correspond to capital X, capital Y, and small x, small y. So let us take some examples here. So let us take these very simple examples. In the first example, you're given that the old coordinates are 1, 1, and the angle is rotated through 45 degrees in the counterclockwise direction. You're asked to find the new coordinates. So the new coordinates are nothing but cos theta sin theta minus sin theta cos theta times small x small y. That is equal to, say, half theta is equal to 45 degrees. Just substitute them. So 45 degrees correspond to 1 by root 2, 1 by root 2, minus 1 by root 2, plus 1 by root 2, times small x small y is 1, 1. That is equal to matrix multiplication 1 by root 2 into 1 plus 1 by root 2 into 1. Root 1 by root 2 plus 1 by root 2 is root 2, minus 1 by root 2 plus 1 by root 2 is 0. So the new coordinates are root 2 comma 0. Next, here also you're given the old coordinates and the angle. You're asked to find the new coordinates. So simply xy is equal to, I'll use the same formula. Here theta is equal to 30 degrees. So cos 30 is root 3 by 2, sin 30 is 1 by 2, minus sin 30 is minus 1 by 2, cos 30 is root 3 by 2, times, this time small x small y is minus 2 comma 2 root 3. That is equal to, you just need to multiply this. So root 3 by 2 into minus 2 is minus root 3, 1 by 2 into 2 root 3 is plus root 3. Root 3 by 2 into minus 2 is minus root 3. 1 by 2 into 2 root 3 is root 3. And the second y coordinate is minus half into minus 2 is 1. Root 3 by 2 into 2 root 3 is 3. That is equal to 0, 4. So the new coordinates of this point are 0, 4. Next, in this question, the new coordinates are given. You're asked to find the old coordinates. So let us write the matrix equation correspond to the old coordinates. So here you have cos theta minus sin theta plus sin theta cos theta times capital X capital Y. That is equal to, so theta is 60 degrees here. So 1 by 2 minus root 3 by 2 plus root 3 by 2 1 by 2 times minus 1 minus root 3. So that is equal to, so 1 by 2 into minus 1 is minus 1 by 2, minus root 3 by 2 into root 3 is plus 3 by 2. Root 3 by 2 into minus 1 is minus root 3 by 2, 1 by 2 into minus 1 is minus 1 by 2. That is equal to minus 1 by 2 plus root 3 by 2 is 1, minus root 3 by 2 minus 1 by 2 is minus of root 3 plus 1 by 2. So these will be the old coordinates correspond to these new coordinates. Now, what happens if the origin is shifted as well as the axes are rotated through an angle of theta. So we have till now studied these two operations separately. Now what happens if both these operations happen? So origin is shifted to the point h comma k, and here the rotation of axis has happened through an angle of theta. Let the old coordinates be small x small y and the new coordinates be capital X capital Y. So if you want capital X capital Y in terms of small x small y, that can be found out in two separate steps. So first let us consider an intermediate coordinate system x dash y dash. Let us consider an intermediate coordinate system x dash y dash. So let us say that with respect to this coordinate system, the coordinates are x dash y dash. So now we know that from our operations, x dash comma y dash is equal to x dash comma y dash is equal to small x minus h and small y minus k, because for x dash y dash only the shifting of origin happened. So origin has been shifted to h comma k, so the new coordinates are old coordinates minus h, old coordinate minus k. Next, now x dash y dash is being transformed into capital X capital Y. So capital X capital Y is equal to the old coordinates now are nothing but x dash y dash. So x dash cos theta plus y dash sin theta, x dash sin theta with a negative sign plus y dash cos theta. So capital X capital Y is this. So you just need to substitute x dash and y dash in terms of small x small y. So that is equal to x minus h times cos theta plus y minus k times sin theta, minus of x minus h times sin theta plus y minus k times cos theta. So these are the formulas for capital X and capital Y, which are the new coordinates. So if you want the old coordinates in terms of new coordinates, so if you want the old coordinates in terms of new coordinates, we can just come back as we have gone forward. So how do we do this? Let us say that you have the new coordinates capital X and capital Y. So first let us go back to x dash y dash, then go back to xy. So what are x dash y dash? X dash y dash are old coordinates with respect to capital X and capital Y. So x dash y dash is equal to capital X cos theta minus capital Y sin theta, capital X sin theta plus capital Y cos theta. And once you have x dash y dash, x is nothing but x dash plus h, y is nothing but y dash plus k. So x is nothing but h plus x cos theta minus y sin theta, small y is equal to k plus x sin theta plus y cos theta. So if you want the new coordinates in terms of old coordinates, this is the transformation formulas, and if you want original coordinates in terms of new coordinates, this will be the transformation formula set. So you don't need to remember this, but just need to understand how to do the transformation. So if you just remember that first you need to shift the axis and then rotate the axis, so you get the answers. So don't get confused, don't rotate first and then shift the origin. That will give you wrong answers, because if you rotate the axis first, this h comma k gets changed for the second step. So we don't want to rotate first and then shift. What we do is we shift the axis first and then rotate. And if you know the individual operations, you can very easily get the final coordinates. Let us look at this very interesting question. So in this question, you're given two equations. 2x square plus y square plus 4x minus 4y is equal to 0. Y square minus 4x plus 4y plus 8 is equal to 0. You're asked to find the new equations of these curves if origin is shifted to the point 1, minus 2. If origin is shifted to 1, minus 2, what are the new equations with respect to the new coordinate system? So this is a very important concept. So suppose if you have a coordinate system and you have some sort of curve in this coordinate system. So with respect to these coordinates, the equation of curve might be something like 2x square plus y square plus 4x minus 4y is equal to 0. Now, if the origin is shifted to some other point, assume that the origin has been shifted to this point. These are the new coordinates, capital X, capital Y. Now, with respect to this coordinate axis, obviously, the equation of this curve will look somewhat different. So, you're asked to find the equation of this curve when observed with the new origin at 1, minus 2. So carefully look at the process that we're going to do. So the old equation will be in the form in terms of small x small y. The new equation will be in terms of capital X capital Y, because the new coordinate axes are capital X capital Y. Now what is the relation between small x small y and capital X capital Y? We have already seen that small x is equal to capital X plus h, small y is equal to capital Y plus k. So these are the relations which connect small x small y and capital X capital Y. Now what is h and k? H and k is the point to which the origin is shifted. This implies small x is equal to capital X plus 1 and small y is equal to capital Y minus 2. Now to form the new equation, you just need to put small x is equal to capital X1, capital X plus 1 in the place and capital Y minus 2 in the place of y. So the new equation is something like 2 times capital X plus 1 whole square plus capital Y minus 2 whole square plus 4 times capital X plus 1 minus 4 times capital Y minus 2 is equal to 0. So you can simplify this. So 2 times x square plus 2x plus 1 plus y square minus 4y plus 4 plus 4 capital X plus 4 minus 4 capital Y plus 8 is equal to 0. So you have 2x square plus 4x plus 2 plus y square minus 4y plus 4 plus 4x plus 4 minus 4y plus 8 is equal to 0. This implies 2x square, so you have y square here, plus y square, 4x plus 4x is 8x, minus 4y minus 4y is minus 8y, 2 plus 4, 6 plus 4, 10 plus 8 is 18 is equal to 0. So this will be the new equation corresponding to the new coordinate system. In this question, you're given that the original coordinates of a point is 2, 1. Now the axis is rotated through an angle of 30 degrees. So with respect to the new axis, what are the coordinates of the same point? That is, if you take the original coordinate system, something like you have point 2, 1. Now we have rotated the axis through an angle of 30 degrees. So the axis might go something like this. So with respect to these new axis, what are the coordinates of this point? That is, you're asked to find this distance and this distance. So this is capital X and this is capital Y. So we can directly do this using our formulas. So capital X capital Y is equal to, so x cos theta plus y sin theta minus x sin theta plus y cos theta. So capital X, capital Y is this and this. So now according to the given question, small x is 2, small y is 1 and theta is equal to 30 degrees. That is equal to, so 2 cos 30 degrees plus 1 sin 30 degrees. So this is equal to minus 2 sin 30 degrees plus 1 times cos 30 degrees. That is equal to, so cos 30 is root 3 by 2, right? So 2 into root 3 by 2 is root 3 plus sin 30 degrees is 1 by 2. So capital Y is equal to, sin 30 degrees is 1 by 2. So you have minus 1 plus root 3 by 2. So x is equal to 2 root 3 plus 1 by 2. Y is equal to root 3 minus 2 by 2. So these are the new coordinates. So capital X, capital Y, the new coordinates are 2 root 3 plus 1 by 2 and root 3 minus 2 by 2. In this question, you're given that you have a curve which looks like 4xy minus 3x square is equal to a square. You're asked to find the angle through which the axes are to be rotated. To eliminate the xy term, that is in the transformed equation, you should not have any xy term. For that case, how much angle has to be rotated? That's the question. So here, the angle through which the axes are to be rotated is unknown. Some condition is given. So we'll apply the condition and try to solve the equation. So let the required angle of rotation, let the required angle of rotation is equal to theta. Now for this particular angle, what is the new equation? So if the angle is theta, we know that small x small y is equal to capital X cos theta minus capital Y sin theta, capital Y sin theta, capital X sin theta plus capital Y cos theta. So this is the transformation corresponding to a rotation of theta. So if you want the new equation, in terms of small x and small y, you just need to substitute the terms containing capital X and capital Y. So what is the equation? 4 times small x is capital X cos theta minus capital Y sin theta times capital X sin theta plus capital Y cos theta minus 3 times x cos theta minus y sin theta whole square is equal to a square. Now if you expand this, you get the new equation corresponding to a theta. Now in the new equation, the condition is that xy term should be eliminated. That means the coefficient corresponding to xy term has to be equal to 0. So let us try to expand this and see exactly what the equation is. So 4x square sin theta cos theta minus 3x square cos square theta. So I'm not very much interested in x square terms and y square terms. I'm mostly interested in xy term, but I'll write everything. So x square times 4 cos theta sin theta minus 3 cos square theta. Next, plus y square terms. Y square term is minus 4 sin theta cos theta here minus 3 sin square theta. So you have a y square term here, a y square term here, because if you expand this square, you get y square sin square theta. Now what is the xy term? So plus xy times, here you have xy cos square theta minus xy sin square theta into 4. So 4 times cos square theta minus sin square theta. Here you have minus 2xy sin theta cos theta into minus 3. That is plus 6 sin theta cos theta is equal to a square. Now, according to the given question, xy term has to be eliminated. So this has to be equal to 0. So this implies 4 times cos square theta minus sin square theta is cos 2 theta. So 4 cos 2 theta plus sin theta cos theta is sin 2 theta by 2. So you have 3 sin 2 theta is equal to 0. This implies 4 cos square theta minus sin square theta plus 6 sin theta cos theta is equal to 0. So 4 cos 2 theta is equal to minus 3 sin 2 theta. This implies tan 2 theta is equal to minus 4 by 3. So this implies 2 theta is equal to tan inverse of minus 4 by 3. So theta is equal to half tan inverse of minus 4 by 3. So tan inverse of minus 4 by 3 is minus tan inverse of 4 by 3. It is minus half times tan inverse of 4 by 3. So we are looking at a clockwise rotation of half tan inverse 4 by 3. So this will be the required rotation angle. In this question, you are given an equation 2x square plus 4xy minus 5y square plus 20x minus 22y minus 14 is equal to 0. This is the original equation of some curve. You are asked to find the new equation if the axes are shifted to the point minus 2, minus 3, and also the coordinate axes are rotated through 45 degrees. So you have both shifting of origin as well as rotation of axis, and you are asked to find the new equation. So if you want to find the new equation correspond to this, you need to substitute small x and small y in terms of the new coordinates capital X and capital Y. So if shifting of axis as well as rotation has occurred, so what are the coordinates? What are the expressions for small x and small y? So we have already learned how to do the transformation. So you have an original coordinate axis, small x and small y. The axes are shifted to minus 2, minus 3, and then rotated through an angle of 45 degrees. Now, to see what the final coordinates are, you can go in 2 steps. So first, if you have a point small x, small y, according to the coordinate axis small x and small y, so let us say that the intermediate axes are x dash and y dash, and the final axes are x and y, capital X and capital Y. Now first, before directly going to capital X, capital Y, let us go successively to x dash, y dash, and then to capital X, capital Y. So first, what is x and y in terms of x dash and y dash? So x dash and y dash are the coordinates of this point with respect to these axes. That is, only translation has occurred. So when translation has occurred, small x is equal to capital X plus h, small y is equal to capital Y plus k. This is our transformation formula set. So now from this formula set, you get x is equal to x dash plus h is minus 2, and y is equal to y dash plus k, that is minus 3. So you have gone from xy to x dash, y dash. Now what are the coordinates capital X, capital Y? What are the coordinates capital X, capital Y in terms of x dash, y dash? Now x dash, y dash are coordinates with respect to these axes. Now you have rotated them through 45 degrees. So x dash, y dash is equal to the old coordinates is equal to capital X, capital Y, capital X, capital Y. So you have cos theta here, and have a minus sine theta here and plus sine theta here. So these are the old coordinates in terms of new coordinates. So if you substitute this here, you get effectively small x is equal to capital X cos 45 sine 45, both are 1 by root 2. So x minus y by root 2 minus 2, and small y is equal to x plus y by root 2 minus 3. So this is small x and small y. So once you have small x and small y in terms of capital X, capital Y, you just need to substitute these terms in respective places to get the final equation. So 2 times small x is x minus y minus 2 root 2 by root 2 whole square, plus 4 times x minus y minus 2 root 2 by root 2 times x plus y minus 3 root 2 by root 2, minus 5 times x plus y minus 3 root 2 by root 2 whole square, plus 20 times this expression minus 22 times the expression for y minus 14 is equal to 0. Now you have to simplify this expression to get the final answer. Thank you.